actually works. Why? Oh my god, I think it works. Crazy.
Siri_bot says Siri_bot has joined Cerebral Love.
Okay. Cool. Okay. Oh. I am impressed. It just worked. To see if the... Hopefully the quality, like everything just looks the same as it usually does. Guess this is what's next. Ghost Gobble. I think this is supposed to be Pac-Man. Solid via Exercism. Okay. Python represents true and false values of the bool type, which is a subtype of int. Interesting. Only two values in this type, true and false. These values can be bound to a variable. True variable is true, false variable is false. Evaluate Boolean expressions using the and, or, and not operators. Wait, what?
Chizumi1212 says hi.
Oh,
what
hi?
website are you using?
This is Exercism. Using and, or, and not. But yeah, hi Cheeto. Like always. Wait, true and true? What does this even mean? How can you do this? False, true, and false. What? True variables? False or true?
Chizumi1212 says sorry. Oh, didn't hear.
It's called Exercism. Let's type it in the chat. It's free.
Salttoserenity says Exercism.
Is this actual code, or are they just saying like
Chizumi1212 says oh thanks.
something and something? I don't even know. True and false. This is weird. True variable. False or true. False variables. What is this trying to show me? False or false. True variable, not false. False variable, not true. Okay. This is a subtype of int. Interesting. True and true. I don't know what that would look like. Maybe I'll have to just use it, like try putting this in the code and using a print statement and just seeing what it prints out. Interesting. This exercise you need to implement some rules from Pac-Man, the classic 1980s era arcade game. You have four rules to implement, all related to the game states. Do not worry about how the arguments are derived, just focus on combining the arguments to return the intended result. Okay. Define if Pac-Man eats a ghost. Define the eat ghost function that takes two parameters. Oh wow. It's taking the false and true as parameters. If Pac-Man has a power pellet active, and if Pac-Man is touching a ghost, and returns a Boolean value, if Pac-Man is able to eat a ghost. Wait, if has power pellet active, is touching a ghost. I think I see. Okay. The function should return true only if Pac-Man has a power pellet active and is touching a ghost. That's logical. Define a score function that takes two parameters. If Pac-Man is touching a power pellet, and if Pac-Man is touching a dot. and returns a Boolean value of Pac-Man scored. The function should return true if Pac-Man is touching a power pellet or a dot. Touching a dot. Oh yeah. Okay. Define if Pac-Man loses. Define the lose function that takes two parameters. If Pac-Man has a power pellet active, and if Pac-Man is touching a ghost. It's just the opposite of the first one from earlier. Returns a Boolean value if Pac-Man loses. The function should return true if Pac-Man is touching a ghost and does not have a power pellet active. False, true, true. Yeah. Define if Pac-Man wins. I'm still kind of wondering about this true and false, true and false. Maybe it's because I don't even know. Anyway, define the win function that takes three parameters. If Pac-Man has eaten all of the dots, if Pac-Man has a power pellet active, and if Pac-Man is touching a ghost, and returns a Boolean value if Pac-Man wins. Yes, this function should return true if Pac-Man has eaten all of the dots, has not lost based on the parameters defined in part 3. Pac-Man has eaten all of the dots, Pac-Man has a power pellet active, and if Pac-Man is touching a ghost. Why does it need these other two parameters, though? Like, why does that even matter? Okay, I'm not really sure about the instructions on number 4. Okay, let's see if it even runs. Oh, nice, it runs. Okay. I kind of want to try, like, putting some of these things in and printing them to see what happens. How? Can I do this? Sure, very well. Why can't you just write, like, print? Oh, wait, no. It doesn't matter, just write print. True variable. Where's the console in this? Like, is there a console? Or did I just do this wrong? This is one of the tests. Is there not a console? Wait, what happened during the Hello World exercise? Oh wait, I'm supposed to do, like, return, I guess. Or actually, I don't know. Maybe I'm just, like, not writing the right code. Or maybe there's no console. Oh wait, I did kind of just put this in this like random. Put this back. Okay, what if I put this up here? I don't know. Okay, actually I will look at the other one. Like, I can't run through this. I don't think there is a console though. It just runs a bunch of tests on whatever you type. It's just like a text editor. It's kind of annoying. Because I don't actually have an IDE for Python. And true. Oh, I guess that's what this actually means. Is just if you have true and false, it'll just always be false. If you have true and true, it'll be true. Wait, true is false or true? False or true? No, but I still don't get these ones. Maybe I'm wrong. No, I shouldn't have closed the extra. Okay. I wonder if I can use Python in Visual. What do I have? Visual Studio. Maybe I should try that. Oh my god, I haven't opened this in forever. How do you do this? Create a new project. Python. Oh wait, but no template showed up. We're gonna see. Oh, I think I have to enable it. God, there are all these optional things. What is live share? This is... is this? Free Python websites. I don't really know if I want to do that right now. False. Huh. Maybe it counts as both or something if it's or. But now I'm starting to think I should be doing this in like an IDE and not in a web browser, but yeah. PowerPoint active touching ghost. Okay. Wait, I'm pretty sure you're supposed to use like if statements and stuff, but they never actually taught them. Wow. So they really do expect you to like look things up yourself on this website. That's harsh. In that case, this is not going to be long until I get hard stuck, just like I did with C#. Does the player have an active power palette? How does Python even know that this is supposed to be a bool? Oh my god, I guess when you assign it, when you use an operator, it just guesses what it's supposed to be. Ghost. Or is it like this? Maybe it's this. Can I do this? Touching ghost. Can I do this? I wonder. Do return. Oh, wait. Is this gonna be wrong? Time to find out. Yeah. I'm not sure how I'm supposed to set this up. Try this down equals. I don't know if it works like this. I do not know how you set this up. That's true. Oh yeah, there's hints. Nine arguments. What? If x is true, then x, else y. If x is false, then x. Oh wait, I think this and or isn't doing what I think it's supposed to. What I think it does. If x is false, then true. Else false. Okay, this one makes sense. X or y. If x is true, then x. Else y. Oh, wow. If x is false, then x. Short circuit operator, so it only evaluates the second argument if the first one is true. If x is false, then x. False. Wow. By default, an object is considered true unless its class defines either a bool method that returns false or a, what is this, len method that returns 0. Constants divided by false, none and false. Decimal. Operations and built-in functions that have a Boolean result always return 0 or false, and 1 or true, unless otherwise stated. Oh, the Boolean operations or an and always return one of their operands. That's so weird. I guess this is what they meant with the true and true stuff. False if oh. I kind of have no idea what this is supposed to look like. This is all wrong, though. I get this feeling I'm not even supposed to write if statements, though. I'm just supposed to use these Boolean things. Okay. Eat ghost. Return bool. Okay. What? Return true or false or something? X is true, then X. If X is false, then X. Else Y. What do you think about this? If X is false, what the? What? What is this? What is happening? Power palette active. How does Python even know this is a bool? Do I use if? I wish there was some more instructions. That's true. Are these by default spools? Wait, I actually have no idea. Two values, true. Oh wait. These are being put in by the user as true or false. So X is false, then X. X is true, then X, X, Y. Second argument, and the first one is true. The first one is false. Wait, I see. guess I am supposed to do if and... Let's try again. If... True. Am I supposed to do like another if? Some of those. This is so bad. I do this. Wait, I'm supposed to do this too, aren't I? God. Is it supposed to be lined up like that? This is horrible. This is not gonna work at all. Okay, so there's clearly problems with indentation. I hate the indentation. V. I have no idea what these ones are. I'm 14. Are there any more tips?
Garcus says you are mostly on the right track.
Really? I feel so lost. I do not understand what's happening. I don't know how to write Python. It's not teaching me the syntax. Like, I'm literally just throwing random words in, hoping something will work. Like, I feel so... This is so sad right now. Oh my god. And also, this shocked me. The way they do these booleans, this is different than I've ever seen. This feels completely different. It's like X, especially this X and Y. If X is false, then X, else Y. But anyway, that's different. Well, I already know my indentation is effed up, but I don't know why. I literally do not understand Python indentation. This is so confusing. I hate this. I hate it here. I don't know what to do. Maybe like look at someone else's if statement, but they don't give me an example of another if statement, which is makes me sad. don't know. I honestly don't know. I think I just need to... I'm probably just gonna have to come back to this sometime. But I just don't have enough knowledge to complete this. And this web editor, maybe it would have been better if I tried doing this in an IDE, where it would like correct my spacing and stuff. If you have any hints, Sea Carcass, I'd be grateful for your hints, so I'm not just completely lost. Oh my god. What do you... Is it that I don't need the else? What if I delete the else statements? Wait, I could delete these. Could I? I don't think anything's gonna happen. Oh, at least I didn't get an error. But still, I mean, failure. None is not false. What? The function returned none. But the test expected that the ghost does not get eaten because no power pellet was active. What is this supposed to return? Okay. False, true. What in the world?
Garcus says your return is nested in the if block.
Is that bad? What's wrong with... Wait, what's wrong with it being nested here? If... Is it supposed to do that?
Garcus says so you don't return anything if power underscore pellet is false.
Oh. Really? Oh, I thought it would just jump to the false statement. If this was, Oh wow. If you think about this, you don't return anything if the power pellet is false. Oh, because this is nested in this if indentation. This is too much. I miss brackets. I need brackets to understand what's happening. Thank you. Thank you, T Carcass. Thank you so much. Okay. So no nesting. Bad nesting. Okay, I've had my daily dose of Python. Thank you. Thank you so much.
How's it going?
Bad. It's going horrible. I'm doing so bad. It took me like, well, one, all my else statements didn't work because I don't know how to I guess all my indentation is wrong, so I just deleted all the else statements. And then two, indentation is so hard. Like, if it wasn't for who is it again? If it wasn't for T Carcass, I wouldn't have understood that this is nested in the first if statement, and then it will return nothing if this is false. Like, I couldn't figure that out by myself. This is so sad. It's going horrible. Sad face. Sigh. Well, now I have to put it back. Okay, there. Oh my god.
The Knight Templar underscore says if statements without brackets is a no for me.
Oh yeah, you use like the C, the good stuff, right? The C languages, the nice stuff.
Garcus says return power underscore pellet underscore active and touching underscore ghost.
It would? Oh, I want to try that. That one's... Yeah, I knew. I just couldn't figure out how to do it. I knew they wanted me. They want me in the exercise to use these, like, or, the and, the not, or whatever, but this is, I don't know how to, I don't know. It's like, I didn't know how to do it. I tried like 3 different things and it didn't work. But I'll try. If X is false. But how does that, this, I don't know. I cannot wrap my head around this. If X is false, then X, else Y. This hurts my head so much. Does C# even have anything like this? I don't even think something like this exists in C#. This kind of operation X and Y.
Says script is a pain because it relies on indentation, which is why I'm now using Godot with C#.
I salute you, Templar. I do. Because this is horrible. It explains it a little weird. Oh yeah, it's...
Garcus says that page explains it a little weird.
I wish they explained it more clearly and gave examples, like instead of just this explanation, like give like plentiful, easy examples would have been nice. This kind of reminds me that one of the benefits of C#, people say C# has really good documentation. And I never thought so, but I prefer C#'s documentation to this. But anyway. Okay, I'm gonna try to do the thing you suggested, T-Carcass, with the and. I think you said if I'm gonna try return? Oh! Really? All I have to do? So I just delete all this, right? Like...
The Knight Templar _ says I was once told that using else is the work of the devil, LOL.
The devil. Oh my god. I thought sleeping was the work of the devil. I'm gonna try it. Return power pellet active, you said, and let's see if it does it. And what's the other thing? Oops, sorry, I didn't mean to pin. I always do that by accident. Oh yeah, and touching ghost. That's it? That'll solve it? Just this one statement, you mean? No way! You can do this in one line? That's crazy. I don't know. Python's weird. Okay, now let me think about the logic. So this would have been X. If X is false, so if this was false, then X. Oh. Oh, this is false. Return false. So it'll just immediately return false. If it's true... Wait, then...
Garcus says true
Y.
and true is true. Any other combination with and is false. Or is true if one or both operands are true.
Oh, true and true. Okay, true. Any other combination and is... Oh yeah, so false and true is false, turns false. Or true and false turns false. Or is true if one or both operands are true. Okay, your explanation was like 1,000 times better than the documentation. They should have just hired you to write it, cause like, wow. But this is still actually, maybe this is why people like writing in Python, because you can like, instead of writing all these if statements, like you can just do this one line for the logic, and that's it. That's really crazy to me. Wow. Anyway, okay, maybe I'll try the second one then, and try to apply what you just taught me. Thank you. Thank you for your help. It's kind of sad that if no one came into the stream, I probably would be on this for like 5 hours. Just on this first one, this Eat Ghost. It's kind of sad to think about. Yeah, anyway. Score. Touching power plant, touching
Garcus says that one-aline is something that can be done in most languages.
Really? Oh wow. I've never done it before though. I'm not like, I never really ever got past like the basics of in any language though, but that's really cool if you can do that in one line. My code is very inefficient and wordy, and I never do the most optimal solution. Sometimes I make things work, but it's usually like in a lot more lines than someone
Sparkus
else could
says
do it.
return A.
Oh. Ah. Oh. Okay.
The Knight Templar
Humanly
underscore
readable.
says we only break things up into multiple lines to make them humanly readable and able to be debugged easier.
Okay, I see. That makes sense. Alright, what was I? Score. Verify that Pac-Man has scored when a power pellet or dot has been eaten. Or... Okay, so it's going to be the same thing, but it's just going to be or, I think. Touching power pellet or touching dot. Probably. This is crazy. Please work. Okay, thank God. Yay! Okay. Lose. Trigger the game loop to end when Pac-Man touches a ghost without his power pellet. Without his power pellet. Actually, I'll be honest. For task number 4, I don't even understand the instructions. Like in English, I don't understand what they want. So that's gonna be really hard. But anyway, let's do number 3, because number 3 should be doable. And when Pac-Man touches a ghost without his power pellet. What would you use here? I mean, I'm guessing it's gonna be like the same pattern. Great, return. But I just used and I just used or. There's also this not.
The Knight Templar underscore says, are you streaming to both platforms without any problems?
Yeah, I think so. When I checked at the beginning of the stream, it was streaming to YouTube, unless that, like, ended by itself. I'm just assuming it's still working. And no, you haven't, like, complained and said the stream quality is, like, horrible or anything, and no one said anything, so I assume everything is working. It's pretty cool. Now I don't have to worry about, like, re-uploading Twitch streams. That'll, like, save me time. And I'm just curious, like, what YouTube... I've never streamed on YouTube before. What it's like as a platform. Like, do people even, like, find streams on there? I don't know.
The Knight Templar underscore says, YouTube.
Exclamation YouTube. A command? Oh! I need to... Oh, wait, that reminds me. I need to add the YouTube chat as a... Like, so I can see it.
Oh. The Knight Templar underscore says to tell people the link.
Well, people are on Twitch. I feel like they're, like, I guess I'd rather Twitch, because I can see the... Like, I can use the TTS and stuff with it. Where at YouTube, there won't be any TTS. And also, now I feel bad, because if anyone did come during the YouTube... I don't think it happened, but if anyone came during the YouTube, I haven't been able to see their chat. So I do need to add that into my OBS. Not on the screen, though, but, like, on the... You know, just so I can read it.
The Knight Templar underscore says, yeah, but you want people to follow you on both, right?
Oh, yeah, I have that linked on my Twitch profile, so they could always just, you know, look themselves, I guess, if they cared enough. Oh, wow, I got a warning. Okay, I just checked my Twitch on YouTube. It says, warning, the stream's current bitrate is lower than the recommended bitrate. We recommend that you use a bit.
The Knight Templar underscore says, I'm on mobile, so don't see you.
Oh, got you. It says, we recommend that you use a stream bitrate of 6,800. I don't know what bitrate I'm sending, but it says, I guess it's, like, lower than they prefer. I don't know, I'll just see how it looks later on. If it looks bad, I don't know. Yeah, no one used the chat or anything, so we're good. But let me still copy and paste the chat into a window. so that I'll have it.
The Knight Templar _ says OBS should tell you.
No, you can only be signed in one thing at a time. I'm signed into Twitch chat. But there's bots and add-ons you can use to combine your chats and stuff, I guess. Oh, bitrate. Oh, yeah. Oh, yeah. Let me.
The Knight Templar _
It's
says
supposed.
No, I meant about the bitrate.
It's supposed to be identical. The bitrate is supposed to be identical to what it is on Twitch. Like I'm mirroring, because you have an option to mirror your settings, and that's what I did with the plugin. That's how it works. Like you can manually adjust them, or you can just copy your Twitch settings. I just like copied everything. But I'm guessing it just gave me that warning because YouTube, like people usually stream at a higher bitrate than on Twitch, unless you're an affiliate. So it's probably fine. Wait, where's the thing? Wait, docs? Oh yeah, custom browser docs. This is what I want. YouTube chats. Oh, nice. Okay, now I can see. Now I can have YouTube chat too. Oops. I'll close. Maybe I will put it down here. Or actually, no, here. I know. Sorry, I'm just like moving windows around. Okay. Oh, it says, by the way, it says the stream's bitrate is 2,700 kbps. Is that bad? Is that a bad bitrate? I'm rounding. But yeah, it says it's 2,700. But maybe I should check what my Twitch one is to see if it's the same. What is it? Settings? Stream. Oh wait, okay, so it's lower than Twitch. Because Twitch is 2,500. Oh wait, no! It's the same as Twitch. It's actually higher for some reason. I'm streaming at a higher bitrate. So we're good. Okay, cool. Okay, back to number 3. Return. Pac-Man touches a ghost without his power pellet. Yeah.
The Knight Templar _ says yeah, I can see that Twitch is 2,500.
Yeah, so I'm streaming 2,500 to Twitch, and I'm streaming 2,700 to YouTube, so it's all good. But it's still giving me a warning, like saying your bitrate's low, because it's expecting me to stream at like 3,000 or something, but who cares? I always stream low. 10,000?
The Knight Templar _ says
wait, what do you mean?
Tells me
you mean recommended?
1000, is that right?
Oh. Hi, Brain. Hello. No, YouTube streaming at 2,700.
Dyslexic Brain says 10K can't be right.
10K sounds crazy. Oh, what the? No, that's not right. That's not what it's showing me. That's crazy. I am not. Oh, hi, Brian. Well, there was another guy named Brian who had a blue name. Wait, there's another guy that had like brain in his name. I think he was named Brian. But you're probably not the same person, but still. This is the coincidence is. Or did they? Maybe they didn't have brain in their name. Maybe I'm just... No, wait, no, they didn't have brain in their name. I'm thinking of someone else. Wait a second.
Dyslexic Brain says a bit racist to judge usernames by their color, lol.
But there was someone who had brain. But their name was like... And then they like got rid of their Twitch account in like one day or something. It's kind of strange. Their name was like Ace Clueless Brain or something. Or Ace Clueless... Oh yeah, no, never mind. It was Ace Clueless Gamer, but then they used a picture of a brain as a profile picture. I see. I'm just like remembering. I don't know. I don't know why I always notice colors, people's colors, and now I associate orange with the UK. Since I mean, it's just a coincidence, but two people who showed up from the UK
Dyslexic Brain
had
says
orange
if people
names.
don't choose a color, they get a random one a fake.
That's true. For a long time, I didn't even know you could change your color. It's kind of crazy.
The Night Templar _ says you've only dropped 17 frames in almost 6,000.
Oh,
so
wow!
looking good on both platforms.
Okay. Thank you, Templar. Oh, wow, that's really cool. I'm really... You know, I mentioned, like, moving, but I'm really not looking forward to that because I'm really worried my internet's going to be bad, but I just hope it's not. Because as a hobby, it means a lot to me. I really like this hobby. Anyway. Right. Trigger game loop to end. Pac-Man touches a ghost without his power-up, so... If... What about active fishing ghost?
The Night Templar _ says how long till you move?
Is it power? It's gonna be around November, or in the fall. I really don't want to. Why stream on both? Oh, because I always stream on Twitch. I just wanted to try out YouTube. I already, like, upload all my streams over there anyway, so I just figured then I don't have to re-upload. And also, I'm curious to see if people use that platform. And I know YouTube has, like, Twitch has, like, no discovery at all. So I'm kind of curious if people will actually discover the stream at all on YouTube or not. Mostly just curiosity. Return power palette active. What am I supposed to do? Is this another and? It's probably gonna, I feel like this is wrong. If it's something related with the knot, this is actually gonna be really hard. Failed. Well, passed the first test, but it failed the second one. I knew this wasn't going to be rigorous. Oh, yeah, Templar. More platforms than YouTube. I think that just sounds like a lot of work. I don't know. I don't think the type of content that I make, I don't think is ever going to be popular. I'm not really trying to make it be popular. Yeah, I just stream mostly for fun and to meet a few people, and I'm really happy with it.
Dyslexic Brain says, hey, since you play no music, why not mute your system sounds?
The Discord ding was from my phone, not the computer. I keep my phone next to me. And I want to hear them. Because I only get those for, like, DMs and stuff.
Dyslexic Brain says, oh, MB.
Oh, and no problem. Return, Don't lose if touching a ghost with a power pellet active. Wait, why is this wrong? My. Actually, if you see what Crisco, yeah, you see it. You see it. It doesn't work. Well, it only works with, you have to manually get it set into landscape. Like, it doesn't do it automatically. I tried it. You have to, I mean, to portrait. You have to manually set it into portrait for it to work. It's literally too much work. I'm not gonna go through and re-upload every single clip. But yeah, YouTube Shorts are pretty great though. Yeah, if I had two choices, okay, in front of me right now, and I can only pick one, the first choice is to grow quickly on Twitch. The second choice is to become a really good programmer. I'm gonna pick the good programmer anytime. I mean, every time. Return. Okay, how do I do this? So, I feel like I'm missing a knot or something. Return. For the ands, they both, if one is false, then the whole thing is false, right?
Dyslexic Brain says adding a camera helps Imo.
Oh, I'm not gonna do that. The only time I'd ever do that is if I was already like really, really popular, which isn't gonna happen, but I'm not gonna add a camera for that.
Dyslexic Brain says doesn't have to be facecam if insecure.
And while I don't share like personally identifiable information, I do share a lot of personal information, as in like personal to me, but not like that kind of information. So that's another reason I wouldn't, like, I'd have to really, really be convinced to ever use like a camera. Like, I'd have to already be super, super popular, and it's like, well, I kind of almost have no choice now that I'm so popular, which is not gonna happen. Okay, I still need to think about this statement though. This is...
Dyslexic Brain says it's not how it works, haha.
Hey, whoever stream it is, it works whatever their rules are, you know? That's the beauty of it, and that's why it's really fun. It's like, you set the rules. But I don't have a hotel.
Dyslexic Brain says I have a hotel. I'll add hot water 24/7 only if I get popular.
Are you sure you're not? You sound like, I'm just saying, you really are reminding me of that one person who came into my stream a while back and then deleted their account. They said something similar to me. And they were trying to convince me to like do a bunch of things to grow my stream. And I was like, you know, I'm happy with my stream. Again, probably just coincidence. I think it's because a lot of people have a No, I really think it's probably just coincidence.
Screw people forcing their opinions on you.
But at least I think for like the face cam thing, like there's plenty of people who do well without a face cam. People hang out with the people they enjoy, you know, they like your content regardless of how you set it up. There's so many ways to do it. Oh yeah, and I'm not trying.
Brain says I'm just saying you'll grow slower, Imo.
If I wanted to grow, why would I be doing Why would I be streaming like 6th grade math? Why would I be doing this? This isn't a game. This isn't fun. I literally was stuck on this first problem for like 30 minutes by myself, just not understanding why my syntax wasn't working. This isn't the type of thing you do because you want to grow. It's something you do if you want to grow, but like mentally grow, that kind of growth. Grow as a person. It just so happens to be, if I grow on Twitch, if I ever do, that's cool. It's not really a goal, but if it happens, like, wow, that would be crazy. I actually have a friend, so one of my biggest inspirations is I had a friend who stopped streaming. Like, they left the internet. They basically, like, removed all their accounts, and I have no idea what happened. I'm pretty sure something happened to them, but I don't know what happened because they didn't tell me. But they were a streamer. They were a small streamer, and they streamed for, like, I think 390 days in a row. Every single day they streamed, and they never had an audience bigger than, like, 3 people, ever. Like, usually they were streaming by themselves. Every now and then, someone would come into their stream. And it was an art stream. He did art every single day.
Says, I find learning streams to be highly entertaining.
He was so committed. And you know what? Even though he didn't have a lot of viewers, and I asked him, like, why do you do it? And he said, I do it because it keeps me accountable, because I want to become an artist. Like, I'm an engineer, and I just want to be an artist. And this has helped me more than anything to, like, improve my art skills. So, you know, he's like, I don't really care. I'm happy with what I do. And it really changed the way I thought about, like, streaming and stuff. 'Cause I barely streamed at that time, but it made me really, like, appreciate that you can just do something and genuinely enjoy it.
Says if it is fun for you, you can have half a viewer.
Hell yeah! If you have fun, you can have 0 viewers, because if you weren't streaming, you would have had... That's the thing, if I wasn't streaming, I already would have had 0 viewers. My entire life, I've had 0 viewers, because I didn't start streaming until probably, like, last November. So everything is like a win for me. I'm happy with everything. I get 1 viewer, and I feel very happy. I feel very satisfied, to be honest. I know some people go on to Twitch hoping, like, having big dreams and hoping to be, like, popular and even make money from it, but it's a really fun activity, just by itself. I like it, and that's the thing that will keep you doing it in the first place. I guess that's why he reached 390 days.
Dyslexic Brain says, love the attitude 3.
Oh, thanks. But I still, again, he was so, like, that guy, he really cared only about what he thought. He didn't care about what anyone else thought. So that's why he was no nonsense. Like, if you came into his stream and said one little thing that annoyed him, he would tell you just like, hey, I want you to leave my stream. Like, he was to the point where sometimes he came off as unfriendly. And I said sometimes I would tell him, I'm like, you know, they didn't mean to do any harm. They were just trying to help you. Like, they didn't, you know, like, they weren't trying to be disrespectful to you. Like, sometimes I would say things like that to him, but because he didn't, like, care what anyone else thought, it just shocks me that he stopped streaming. Like, I swear, something must have happened. Something must have bothered him. Something got through to him. It surprises me a lot, because I thought nothing. Like, he never cared about what anyone thought. But maybe that's not true. Anyway, this goddamn statement, I need to solve this. So the game ends if you don't touch a power pellet and you touch a ghost. So
Dyslexic Brain says, I think we all care to some degree.
Yeah, I think you're right. Even when people don't show it, we all have feelings. I just don't think he was the type of person who, like, showed his emotions. I kind of feel bad, and I wish we were better friends, because we weren't really that close, but he was always, like, really nice and helpful to me. But, like, I feel bad that he was all by himself.
Dyslexic Brain says we're herd animals deep down.
Oh, thanks, Templar. Hey, good luck in the garden. You got this. Don't. Why are you making a sad face? Isn't it? I would love to go gardening right now. I don't even have. I can't garden because there's like no space here. But like, that's awesome. It's such a good thing to touch grass. Seriously, if you have the opportunity, you should always take it. Not everyone on the internet gets to touch grass.
The Knight Templar _ says I hate gardening. Tempted to
Concrete all over? Oh my god, I've never met someone so has so much antipathy towards gardening. But it's so relaxing, and you get to be one with nature. Don't be like that.
Says, yeah, gardening is
shush.
LOL.
You people in the UK don't know what you're talking about. It's nature. It's beauty. It's, becoming one with the universe. That type of thing. Enjoy yourself. Like, reflect on all your, the history of your ancestors who, had to invent agriculture and all that jazz. Power palette and touching ghosts. So these would have to both be true. Alright, I'm just gonna scroll up and read that comment again. Oh wait, no. Why is it so easy to pin stuff? I hate this. Okay, where's that one comment? That one was really helpful. T. Cargus. True and true is true. Any other combination with and is false. So it has to be true and true. So then why doesn't this work? Okay, this is the true one.
Dumb Cresco Sparrow says the backbreaking work of having to dig weeds out between cracks in 60 feet of paving slabs isn't beauty LUL.
I never had to design your garden with paving slabs.
Dumb Cresco Sparrow says gardening be hard work. Yo.
Everything is hard work. Hard work is no excuse.
It's just says I gotta maintain what's already there, right?
Is it worth it or not? Well, literally everything's hard work. There's just nothing in life that's not work. I wish there were things that weren't any work, but literally everything. Everything! There's no escaping it. Okay, so this one passed with true and false. So true and false returned. What was it supposed to return? False. True? And false returned false. This one is true and true, return true, but it was supposed to return false. Why is true and true wrong though? Active power pellet, touching ghost. Oh yeah, I see. That should return false because you're not losing. True, false, true. Wait, no! If it's true and true... Oh, wait, no. Never mind. True and true is supposed to return false. It's supposed to return true if it's false. False, true. False, false. True. So you only lose if you touch the ghost without the pellet. I don't know. Maybe you can't do this in one statement. I don't want to try to do it anymore. I give up. It's too hard to think about.
Eat It Cheeto Puff says I just ordered some new phone cases online.
If power pellets Oh my god. Why is my tab not working? A power pellet active. Okay. I'm gonna do it the way that's probably not, you're not supposed to do it, but I'm gonna do it anyway. Power pellet equals false. If touching ghost equals true, okay, return true. Wait a second. Couldn't I have just did the thing I had earlier? But with, wait, actually, I'm gonna cut and paste this, because I think...
says it's okay to use if statements to write and reason it out the long way.
Aw, thanks,
Condensing
Tarkus.
code comes with usage and experience.
You're nice. But I have an idea, I'm really trying. I really want to use the things you taught me, and I have an idea. What if I did, like, I'm gonna put the old code back for, like, 1 second, and try the and statement, but this time I'm gonna return, like, I don't know, maybe I'm gonna try using, like, a not. Maybe it'll work. I'm actually not sure. Okay, so, what did I have? I had return, oh wait, damn, I feel like there's a way. Is there? Do you think you could write this? You don't have to tell me the answer if you don't, but do you think it's possible to do this in one line? Like, with the ands and ors and stuff? Am I just missing it? Because I really want to try to do it for number 3. There, okay, I'm gonna try. I really want to try. Okay, it's worth it. Let's try it. Okay. Return power pellet active and touching ghost. I know there's gonna be a not somewhere. I just need to figure out where logically it makes sense. I feel like there's gonna be a not. Because, okay, it'll return true if both of these are true. Not power pellet active and touching ghost. Then I want it to return true. I think this makes sense. Yes, okay. I knew there'd be a sticky knot. I really had to think. This is really freaking hard. Also, I don't even understand the instructions for task number 4, so I'll just try to understand what they want me to do in English. We'll see. Don't win if all dots. Wait, so it takes has eaten all dots, power pellet active, touching ghost. The thing that I don't understand why these two things. Why does this function take these two parameters? These parameters. Like, how does this relate to winning at all? The has eaten all dots makes perfect sense, but these two, I literally don't understand why those are parameters. Trigger the victory event when all dots have been eaten. Parameter has eaten all dots. Bool, has the player eaten all the dots? Makes sense. This one's weird. Does the player have an active power pellet? Don't know why that matters. Is the player touching a ghost? Don't know why that matters. Oh, because you're supposed to die? Why can't you just use the lose function and then instead of putting all the variables, the arguments back into this one? Return bool, has the player won the game? Okay. So it's just like the task 1, 2, and 3, but more complicated. Because now there's like 3 things to think about. Which I can barely understand this in English. So, well, the has eaten all dots, it has to be true. Can you combine and or? Can you be like and or and like all of those together? Because that sounds like it'd be really crazy. I don't know how Python could handle mixing and or together. But okay. Return has eaten all dots. And I don't know if I can do this in one statement or not. I don't know. I don't think I can. If you're still around, do you think the win function can be done in one line? I don't know. I don't think so. Now I'm about to use if statements.
Garcus says yes it can.
What the? No way! All three of these? Oh my god. Okay, I should try it though. No. Oh, you said yes earlier. So you can combine like ands and ors. But like what the? That sounds so weird. Oh my god. Okay. Hexagonal dots. This needs to be true. Because you can't win unless you eat all the dots. The power pellet only matters if you're touching the ghost.
Says when you think about it, you might notice that you can reduce the 3 given inputs into 2.
Really? I bet it's gonna be like these two. I feel like these two, they go together. Like these ones, because these are dependent on each other. But I'm not sure how to like put them together. It has eaten all dots. This is like separate from these other two. Oh, I know. You lose calling the lose function because this is a boolean too. Probably. So like has eaten all dots and not lose because not lose because you don't want to lose. And then plug in. Because I think I can do this. I can call the function again, right? The one I just defined. Power pellet active touching ghost. I hope this freaking works. Shouldn't the keyword be like in a different color? Why is... Oh no. I feel like it's the syntax is wrong. Oh my god! I thought this knot was supposed to be like... Oh wait, I couldn't see it. It was just too... Like, it's hard to see when this font is small. It was purple. I thought it was like black. So I was like, oh, it's gonna give me an error. Thank you! Oh my god! Dude, T. Carcass, your hint was so good. That was such a good hint. You're like, there's a way to group them, and I'm like, how do we group things though? It's like, wait a second. That's why we write functions, because you can like squish, you know, things together. Oh my god. You're the best, thank you. I'm not sure like how Twitch works with, because I'm not an affiliate. Well, I didn't do the affiliate thing yet, but I kind of wonder, like for people who are like affiliates and stuff, is there like special roles you can give people, or like temporary rewards and stuff? Because if I could give you like a genius badge, I'd give you something for that. Because that was really good. Because you didn't tell me the answer, but you gave me a really good hint.
I did not do much. You were the one who figured it out.
No, but I couldn't have. I really needed the little, like, just a little push, just a tiny little push in the right direction to know, to be able to figure it out. And if you didn't say that, but that was like so good. Damn. Because it's actually really hard to give someone a hint without actually telling them what they're supposed to do. And you did it perfectly. Like, you're like an expert at it. I'm really impressed. I wouldn't be surprised if you're like a computer professor or something. That's how impressed I am. Like, wow. Yeah, I'm gonna submit it. Oh my god, I can't believe I finished this whole thing. I know like anyone else would have been able to finish this in like 5 seconds because it's easy, but like, since I was stuck on the first one for like 30 minutes, I didn't think I'd be able to get it done at all. See? And the system can't even give me feedback because the feedback you gave me was so perfect. Could review from one of our Python mentors to be feedback. It is how you make it more idiomatic. Okay, whatever. Continue. Wow. That was hard, but it was possible. It wouldn't have been possible without you. So, oh my god. Now what to do? Oh my god, do I really want to like keep suffering? Wait, in progress? I thought I submitted. Did I not? Why is it in progress? This should say complete. Huh? Oh, is it because I need to publish it or something? Submit. Continue. Oh, mark is complete. Wait, I feel like you understand. Oh, I just thought it would mark it as complete all by itself. Like, do I really have to do it manually? Oh yeah, I'm happy to share. Potion code.
Garcus says I teach some classes on data structures.
Oh, okay. You're good.
I'm just a simple software developer
I'm
with
really
about
impressed.
15 years of experience. Getting
Ooh,
old.
that's a lot of experience. Wow. Dang, you're good. I almost wish you could put this on your resume because you're good. You're a really good teacher. You need to publish like an online course and make a lot of money, as I think. I'll be the first to give you a 5-star review. Wow. Anyway. Oh yeah. I guess publishing it and it automatically marks it as complete. Oh, what languages do you use? I'm curious. I'm always curious what languages like professionals like to use. I have a friend who's a professional Python developer, and then I know someone else whose main language is C# professionally. It's pretty cool. And also C++. Wow. I was in so much pain before, but now it's like it all went away. That was pretty fun.
Garcus says currently I use Go, JS,
Ooh.
Java and little bit of Python for scripting.
Oh, Go's the one with the little bear thing, like the cartoon that looks like the logo. It looks like it was drawn by an elementary school student. That one. Python. Cool. Is it Java? Yeah, the first language I ever tried using or started using was Java, but I haven't touched that in so long because it was part of a class I took. They made us use Java. It was like computer science, like 101, you know, the very first one you take in college, but I never went past that, and it was really hard. I felt like I barely got through it. numbers. Wait, math. Sad. Yeah, the Pac-Man one was kind of more fun. Whatever. I'm gonna keep going. Let's keep going. I should try. Okay. 3 different kinds of numbers. Ints, floats, complex. However, in this exercise, you'll be dealing only with ints and floats. So whole numbers. Digits in Python have arbitrary precision. The number of digits is limited only by the available memory of the host system. Oh, that's cool. Arbitrary. Floats are numbers containing a decimal point. 9. Floating point numbers are usually implemented in Python using a double in C. Oh. 15 decimal places of precision. But will vary in representation based on the host system and other implementation details. Oh wow. This can create some surprises when working with floats, but is good enough for most situations. You can see more details and specials in the following resources. I'm not going to read those. Wow, the name of the site. Python fully supports arithmetic between ints and floats. It will convert narrower numbers to match their less narrow counterparts when used with the binary arithmetic operators. I'm not sure what the double... Oh wait, when division with... Oh. Slash or double slash returns the quotient. And percent returns the remainder. Wait, what's the... I don't get
Darkus says not surprising, a lot of CS courses are in Java. My college was about 40% C, 40% Java, and remaining was assembly, JS, Python, Lua, Elixir, etc.
Assembly? That sounds really difficult. Was assembly hard? Because isn't that like super low level and not like I don't even know how people know what they're doing when they work with things that are that low level. Elixir. It's kind of weird because for a while, I don't know why, I thought Lua was like a really recent language. I had no idea it was so old. Since there's like a lot of good things about it, I've heard. Like I think I once heard that it's kind of like Python, but if Python wasn't as like slow and stuff. Something like it's also like used like a wrapper, but like it's cleaner and nicer and stuff. Python. What was it? Oh. Yeah, I don't know what the difference between the slash and double slash is. Oh.
Darkus says it was crazy hard to get good at assembly. At the same time, it taught me a lot about how software works with hardware.
I see. That's really cool though. God. Assembly. It sounds so scary. Does every language go down to like assembly if you like look deep enough? Turns the quotient. Alright, I'm actually gonna Google the difference between There is no difference? Oh, wait, no. Oh, this is a different question. Oh. Let's see what this one says. Oh my god, ads! Returns perform standard division. Oh, okay. Where's the other one? Performs division returns the largest integer that is less than or equal to the division result. Result dividing 10 by 3 is 3.33. Oh, okay. Okay. Oh wait, I wonder if they explained it later on. Oh yeah, they kind of did. I should have just kept reading. Python considers ints narrower than floats, so using a float in an expression ensures the result will be a float too. Oh, that's what they mean by narrow. Okay. However, when doing division, the result will always be a float, even if only integers are used. The int is wide into a float here. And a float type is returned. Okay. 12. 1. Division always returns a float. Remainders. Oh, cool. If an int result is needed, you can use truncate the result. Wait, 7? Oh yeah. To convert a float to an integer, you can use int. Also, to convert an integer to a float, you can use float. Ah. Okay. I'm pretty sure this same exercise was actually in the C# track. And I think I did this one in C# before. Hopefully it won't be as hard. Like, hopefully it's not going to be significantly more hard in Python.
Garcus says some languages skip the assembly step and compile straight into machine code. Or just-in-time compilers convert their bytecode straight into machine code on runtime.
Oh, cool! I did not know that. Do you have a programming language that you hate? Personally, you just do not like using at all? Or wouldn't really want to ever use?
Garcus says JS.
Really? Wait, don't you use that though? Oh, okay. You just like have to, I guess. Oh no. What do you not like about JS? I'm so curious. Your friend Chandler plans to visit exotic countries all around the world. Sadly, Chandler's math skills aren't good. Hey, I'm Chandler. He's pretty worried about being scammed by currency exchanges during his trip, as he should be, and he wants you to make a currency calculator for him. He should find someone else. Here are his specifications for the app. Estimate value after exchange. Create the exchange money function, taking 2 parameters. Budget, the amount of money you're planning to exchange. Exchange rate, the amount of domestic currency equal to 1 unit of foreign currency. Oh, by the way, T. Carcass, also, have you ever made any games before? Like, that's my primary interest in programming, like, why I'm interested in it.
Garcus says there are so
because
many ways
I really
to
like
achieve the
games.
same goal. code ends up looking like a complete mess.
Oh. Interesting. Oh, so in a way, you don't like to have too many options. 'Cause... Oh. Exchange rate. It's funny. I know you're describing JavaScript, but for a second I thought you were describing my code, because that's what my code's like always. Even if there aren't many ways to achieve the same goal, it just still looks like a mess. Arrow function. What
Marcus
the
says
heck?
we have regular functions and arrow functions, ARR filter, and ARR for each that can do the same thing.
Oh my god. I have no idea what those are, but... Wow. Honestly, when there's like many different ways to do the same thing, it ends up like confusing me even more. But, wow. Sorry. Oh yeah.
Garcus says got to remember the rules on when JS does type coercion and your int becomes a string and the whole code breaks.
Oh my god, that's what type coercion means? It just like forces your types to change into other types? That sounds horrible. I love how it's called type coercion. That sounds amazing. They're holding the types at gunpoint. It's like, become a string. The amount of money you plan to exchange rate, the amount of domestic currency equal to 1 unit of foreign currency. Okay. This function should return the value of the exchanged currency. Wait a second, didn't I thought I did something like this like earlier. Even in the Python track, there was like a... No, I didn't. I'm just imagining things. That's crazy. I remember doing that, but... Oh right, maybe I started it.
A needed feature in a language like JS.
Oh, I see what happened. Yeah, that's why this is familiar, because I actually started on this one. But I never finished it, because I accidentally skipped ahead, so then I... Oh, okay. So I don't have to read all that. But I don't remember reading that before. Need a feature in a language, like, oh. Oh, because of, like, what it's used for? Oh.
Garcus says, like, how do you sort an array that can hold different data types? Easy, convert all values into strings and then sort.
Okay. Oh, so that's I see. It's really interesting. I think that's when I stopped. So the furthest I've ever gotten in programming was with C#, and I think it's around when I started learning about arrays is when I stopped. So I never really like ever figured those out. But that's where things started to get very complicated. Like when you start like working, like storing data and then trying to get it back, and yeah. Okay, what was task 3? Get value of bills. The value of a bill. Number of bills. Total number of bills. Calculate value of the bills.
Garcus says, so you end up with funny things. 5, 2, 44 sorted is 2, 44, 5.
Wait, 5, 2, 40, 2, 44, 5. Wait, why does it happen? 5, 2. That's not even alphabetical order, is it? Return. I guess denomination times number of bills. That did not work. What do they want? Test data. Number of bills. Not the test expected. Oh wait, get value. Oh wait, no, I did it right. Okay, I was confused which one I'm on. Next one's get number of bills. Total starting value. The value of a single bill. Number of bills that can be obtained from the amount. What is this even asking for? Oh wait, I think I see. Like, why a single bill? So division. But I think you're supposed to use like the floor. Return.
Garcus says, and when we sort strings we compare by character, so when comparing string 44 with string 5, we check for BS5. First character in string A is smaller than first character in string B, so whole string A is smaller.
That makes sense. I don't know why I thought in my head they're getting converted into English words. That's literally like really stupid of me. Never mind. Like you can have numbers as part of a string. Too, like string representations of numbers, like duh. Oh my god. Oopsie. But wow, I can see how that would be like a big headache though. Return. Wait, denomination. Yeah, amount. I think amount's like how much you have. Denomination.
Garcus says, on the other hand, most Go and Java codes end up looking the same because they are very strict on what can be done.
I see. That's also a good thing too, don't you think? In the case of, like, if you're reading someone else's code, like, and maybe you don't know that language, like, you can still follow. It's easier to follow what's happening since they look so similar. I really like features like that. Like, it wasn't so hard. Like, C# and Java were like super similar to each other. Like, they looked similar and had a lot of similarities, but Python looks very different. So like Python's kind of a pain, especially with the indentation. I know you're supposed to indent in any programming language, but just have it forced on you like this. It hits different. Okay, calculate leftover after exchanging into bills. Which one is this one supposed to be? Get leftover of bills. Oh. Total starting value. Value of a single bill. Return the amount that is left over given the current denomination.
Karkas says, yeah, reading a known and strict code structure is much easier.
Yeah, in a way, when I get to read that, like, I feel spoiled. Because I remember I once tried looking at, like, F-sharp code, and, like, it was so weird. Like, I had no idea what was happening. And it was, like, it was just, like, something basic. It was, like, hello world. But it was still, like, I'm like, what is any of this? I don't know. F-sharp? It just seems so weird. My programmer friend, makes this joke that, like...
Karkas says, I have never used C.
Oh, cool. I mean, cool that you had no problems following along. Yeah, it's really easy. It's nice to look at C sharp. I guess maybe some people complain that it's like too wordy, but I like it. I appreciate it for the extra clarity. I think it's worth it. It's worth it for the extra clarity. Return. I have a starting bill. Wait, get leftover bills. Given the current denomination. Oh, remainder. Where's my percent? Remainder. Oh, I think I did it wrong. Oh wait, why did I write float? Amount. Okay. Next. Oh wait, there's only one more left. Oh my god. Hooray. Get... Oh wait, exchangeable value. The amount of your money you're planning to exchange. The unit value of the foreign currency. Percentage that is taken as an exchange fee. The value of a single bill. Maximum value you can get. I kind of wonder now if I'm supposed to use some of these other functions inside of this one. But I forgot what all of these do, to be honest. Let's see. Is budget and exchange rate... Oh, it is an exchange money. Return budget divided by exchange rate. Exchangeable value. Maximum value you can get. Spread denomination. Exchange fee. The value of a single bill. Oh, thank you, whoever followed. I don't know if that was YouTube Carcass, but whoever followed, thank you. Budget. Wait. How do I do this? I'm like thinking now, like, just the math. Like, how do I do this? How do I do the math of this? Like, even in English.
Garcus says, but have fun with learning.
Oh, thank you.
Time for me to do some cooking.
Yes! Cooking!
Hope to catch your streams in future.
Aw, thank you. And thank you so much for your help. Really appreciate it. Thank you. Because I would not have moved at all. Like, I would have just been stuck forever in limbo if you didn't show up and save me. But thank you. Good luck cooking. Have fun. The other programmer guy went off to do gardening. So he's gardening, you're cooking. You guys are living it up. And I'm just here, not touching grass or doing anything. But bye. Exchangeable value. Currency. So you would take the budget. Wait, denomination. Okay, let me just read what the instruction says in detail. Taking budget, exchange rate, spread, and denomination. Parameter spread is the percentage taken as an exchange fee, written as an integer. It needs to be converted to decimal by dividing it by 100. If €1 is equal to 120 USD, and the spread is 10, the actual exchange rate will be 1.32. Because 10% or $1.20 is 12. And this additional fee is added to the exchange. This function should return the maximum value of the new currency after calculating the exchange rate plus the spread. Remember that the currency denomination is a whole number and cannot be subdivided. The currency denomination is a whole number. Oh yeah. Maximum value of the new currency. Alright, because you want to exchange your money into the new currency. So budget divided and it's divided by exchange rate, right? Maybe I should just look at some of the older functions. Budget and exchange rate. The amount of domestic currency equal to 1 unit of foreign currency. Domestic. Currency is USD and you want to exchange USD for Euro with an exchange rate of $1.20. Then $1.20 is equal to 1 euro. Oh wait, that's multiplication. Right.
Casper Caper 17 says hello.
Hi Casper! Ah! Hi! Look, I'm doing Python. Well, I'm actually, it's funny because I'm more focused right now on the math rather than the Python of, because money exchange stuff. Okay. Well, here I did. How did I even fix that? I did the budget divided by the exchange rate. I'm the one, I did write this, but I kind of forgot. Why did I do, like, this is what you're supposed to do, but why is it not budget times the exchange rate? Now that I think about it. Like, where's the example for number 1? Like, if the exchange rate is $1.20. Oh wait, I guess I see. Oh wait. I'm dumb. Well, yeah, never mind. You would divide. It makes sense.
Casper 17 says Python is a great language.
Yeah, I'm starting to like it a little bit more the more I learn about it. But it's very confusing to get started with. It looks very different from C sharp, and then you have lots of like, weird things. And 27, 5. Okay. I'm gonna use that. Wait, can I at the beginning? Because there's also this the spread that I have to do down here. Alright, so I wonder if I can just call exchange money. Oh wait, but I also need the, what is it called? I'm gonna put pass back real quick. So you need to exchange the money, and then I need the spread. Percentage is denomination. Why does that matter, though? Oh. Maximum value of the new currency after calculating the exchange rate plus the spread. The currency denomination as a whole number cannot be subdivided. What? After an exchange. $1.20. Wait a second. In this case, oh, this would be like the euro's worth more. Wait, no, $1.20 USD. Oh yeah. Calculate currency left after an exchange. What is left from the budget? Yeah, don't need to worry about that. The value of the bills. This is multiplication. Calculate number of bills. Left over after exchanging bills. What?
Casper Caper 17 says this does really feel like lots of info about money, and relatively little about coding.
This one's more about, yeah, because that's how it's supposed to be. This one's less about the coding part, because it's supposed to teach you like ints and floats and using the operators, multiplication, and addition, division, remainder. Like, that's what this whole thing is about. That's why it's super mathy. And I'm like trying to understand how to do the formula. Okay, I don't understand why I need the denomination. I mean, I understand why I need the budget, the exchange rate, I need the spread. What the heck am I supposed to do with the denomination? What is this for? The function should return the maximum value of the new currency. It's funny because I actually did this before in C#, so I did figure it out. Maybe I'm like more stupid than I was in the past, which is pretty sad to think about. after calculating the exchange rate plus the spread. Remember that the currency denomination is a whole number. This is like how many bills you're gonna get, I guess. Maximum value of the new currency. But why do I need the... What's the denomination being used for in this?
Casper Caper 17 says the thing with Python is that you don't really explicitly use the variable types most of the time. It is useful to know though.
Yeah, it's crazy. You can't even specify like exactly what type you want. It just like decides for you, which is really crazy. Denomination. Okay, well, let me look at spread first. It needs to be converted to decimal, say dividing it by 100. So spread is like 10.
Casper Caper 17 says if you want you can also just dump a function as a parameter of another function. Create some really funky things.
Okay, that stuff's fun to do. So after calculating the exchange rate plus the spread. The currency denomination. So this is giving me what? Like the number of bills or something? Of that currency denomination? But that's not what it says. I have to exchange. If it's $1.20 USD. Look at the example more. Oh my god. If €1 is $1.20, spread is 10. I have to exchange. Oh, wait, 10% of $1.20. Okay. So divided by 100, multiply this by 0.10. But is it supposed to be like the exchange fee is per dollar? Or is it, no, it has to be per dollar. Maximum value of the new currency. I don't know why I really just don't understand what the denomination is used for. These other ones, it made sense what they were using it for. Like in this case, the answer is 80. Well, wait a second. I bet it's like saying... Because these are the bills you're going to get back. Okay, well, obviously you need the exchange rate. I'm gonna figure out, Should I use parentheses? Probably. Times. I'm actually not sure. But probably. Times. Wait. Oh, yeah. Times. Spread. Divided by 100. Budget. Oh wait, I should use a new rate. Divided by oh my god. Denomination. This is gonna be so wrong. Oh wait, let's get rid of pass. Yeah. I think this is not the math they wanted. Wait, let me get a calculator and see if I can. I don't think I'm doing the math right. And I don't feel like I understand what it's asking me for. Math. Okay. So they wanted to do 1.2 times 6.10. So that's 12. Add it to the exchange. Is that the problem? I just didn't add it? Wait, 10% of 120 is 12 cents. So $1.32. Because 1.2 times 1. Oh yeah. Okay. Wait a second, I did it. I guess that's the problem. Okay. Spread divided by 100 times exchange rate. More parentheses. Exchange rate. Wait, crap.
Casper Caper 17 says the quality of this course is better than the one my university offers at first sight.
I don't think so. There's like literally almost no explanation. You basically have to look everything up on Google. This isn't a course, it's just a bunch of problems that you have to solve. But I think the creators put a lot of thought into the problems they picked. But still. Oh my god, I don't even know what I'm doing anymore. Times. There's no way this is what they want.
Casper Caper 17 says the 2-hour lectures are not particularly useful for learning programming. Googling works best most of the time.
Damn stupid math. Return. Oh my god, okay. Well, I know I want I need the spread times the exchange rate, and that's like the fee per dollar, I think, that's being exchanged. So it's like, oh my god, I'm just gonna look at it again. They didn't explain this. They could have explained this better. It's the hard thing. It's not super clear. It's 12 cents. This additional fee is added to the exchange. Oh wait, added to the exchange. Well, yeah. I just need to add it to the exchange. Times exchange rate. Exchange rate. Exchange rates plus there. Exchange rate times that should be right. Then you take budget divided by exchange rate. Is this what they want? Damn it. Denomination. The value of a single bill. Well, I guess I could check to see if they're doing what I think they're doing with my calculator. Like in this one. 95 divided by 5 is 19. Wait, what did that tell me? Should be type. Okay, I still actually don't know what's happening. When it's supposed to be like $1.32 in the example. Let me try 127.25 divided by 1.32. 96.4. Wait, so this is identical to each other, except one is using 20 and one is using 5. What is that last number doing? So there's no division with this number. Oh wait, I see. You want to, how would I do this though? Okay, I know what's happening now. Okay, so for this part, divided by denomination times denomination. I think that's one way we could do it. There. Aha. I did it. But I kind of want to see if I can use... I want to, like, call the previous function. Like, budget divided by exchange rate, for example. Because I think that would be fun. Probably unnecessary.
Casper Caper 17 says well done.
Thank you. This math... Seriously, this was so freaking difficult. Cause I just didn't understand. I didn't understand what they wanted. So I had to keep, like... The English was so bad. They explained this with, like... Their explanation was so poor, literally. Like, I figured it out by playing with the numbers. I'm like, oh, wait, I know what they want. I see what they're saying. They're saying you don't get change. Like, they literally could have said, you don't get change. And then I get, oh, that's what the denomination means. It's like you have to get rid of the change and, like, keep the bill part only. But they didn't say that, so I had to figure it out myself. So annoying. Like, minus all the code. Like, dang. Okay, well, I am going to try to substitute some things in here just to make it, to play around with it a little bit more. Okay, it still runs. So what else can I substitute? Have the exchange rate. I feel like I can do more to it, to like use some of these other functions, maybe. Amount denomination. Is a leftover. Is that what I did here? I mean, I could do it differently. I could actually use this one instead. I decided to go for a different way. To be honest, but I don't know. Maybe I think I'll just keep my way. Maybe I should change it. Actually, even though I know I could, calling this function works, it makes it look uglier, and it just like makes it longer. It's probably not good to do that, to be honest. Square divided by 100. Do I have anything about the exchange rate? You know what? Actually, I'm gonna take this and I'm gonna comment it out because I want to try doing it a different way with the functions I have. So, wait, how do you write comments? I thought it was hashtag. Oh, it is. Okay. So we'll just do that. Okay, and now I can play around. So if I were to use these functions instead, denomination times number of bills. Oh, for one, I could actually do this, put this whole thing into the function, the, what is it, get number of bills. Because this whole thing is actually the amount. This is gonna look horrible. Denomination. Like I could do this. Oh wait, I'm missing something. Extra. Oh wait, no? That doesn't work. Get number of bills. Alright, I think I need another. Oh. Parenthesis. That doesn't work. So exchange. Oh wait, because it's giving me the wrong answer. Oh yeah, because I still need it the times denomination. I made this code look so much worse. Wait, what did I do? Oh no, sorry. It was this, but I still think there's more I can do. Oh my god. If I can get it to work. Exchange. Why does it not work now? Can I not plug something in like this as one of the arguments? I'm surprised this doesn't work. Result. Because this should be the same thing as what I have above. Wait, get number of bills. Oh wait. Amount divided by denomination. Oh wait. I'll get rid of that. Yes. Wait, get number of bills. Times denomination. There. Oh my god, why did I say to refactor this? Okay, so that works then. Then we just need to do... I guess that's good enough. Exchange rate denomination. Yeah. Okay. I also kind of want to do what I had earlier. So I think this was actually better. But I still... Oops. Okay, so I want to make sure it still works. I'm gonna comment it out. Oh god. Oh, I'm just missing a... Okay. Original. Comment it. Doesn't comment to me. Okay. Nice. Get number bills. Okay, I think this is good. how do you submit these? Oh, like this. Phew. Okay, now I feel all Pythoned out. Apparently, oh wait, I'm gonna do some Khan Academy. Hold on, I'll switch my category. Oh! Sorry, my TTS broke. Wait, are you still there, Casper? The, oh! What does the double slash do? That,
Casper Caper 17 says you've done a lot.
It gives you an integer. Like, if you do a division, it drops the decimal. Like, for example, like, if you get this answer, like 3.333333, if you use the double slash, it won't give you 3.333. It'll just...
salttoserenity says 3.333333.
It just gives you 3. So no remainder. Like, no... You just get a whole number. It drops the extra. So, yeah, that's all it does. That's why I used it, because you don't get change. That's why I said their explanation of the problem was bad, because they never said no change. I was really confused. That's actually what they wanted. That's why they have that one argument called the whatever. It's to get rid of the change. So yeah. And that was like annoying. Oh, I guess my TTS is working again. That's good. That was hard. Oh yeah, that's right. I need to change my stream category. So they added some new stuff to Khan Academy. So some of my old courses that I completed, like they added some new topics, so they're not complete anymore. So I have to go back and fix them now. Sadly. Okay, I'm gonna change my category. Right.
Casper Caper 17 says, oh, that's annoying.
Yeah, it was. Very annoying. 8/10. Is that bigger than 4 out of 5? Wait.
Casper Caper 17 says, I am watching Olympic canoe simultaneously.
Oh, cool. 8, 10. What, that's 5, 4. Equal. Ten, 11, 12, 13. 14/5. Okay, and then 5 is 10. 28. So okay, 3, 6, 7, 2. 16. 1. 6. 16. 2. Oh, equal.
Casper Caper 17 says my tip would be to subtract the whole numbers, then you can see it very swiftly.
Really? You can do that? I didn't think about that. Yay! Okay. So I guess I'll go through and do the unit test, because it's actually not at 100%. Well, it says 100%, but it's not, because it needs to be at 200 points. So... which means I have to do the unit quiz. Jesus Christ, there's 23 of these. Wait, I kind of don't want to do it, honestly. Yeah,
Casper
whatever.
Caper 17 says you can do the same operation on both sides, and the inequalities/equalities stay the same.
Oh, yeah, you're right. Algebra. Yeah. I didn't think about trying to do that. Like, that would be faster to just subtract get rid of the holes. That's smart. Just sometimes the bottoms weren't the same. Maybe that doesn't matter. 2, 3, 4, 5. Wait, shaded area. 1/3 plus 1/3 plus 1/3. 2, 3, 4, 5. 2, 3, 4, 5. What the? Oh, choose 2 answers. I didn't see that. Dumb. It's okay, I didn't get it wrong. 3 bags of frozen vegetables. Each bag is 5/8 full of vegetables. He plans to make vegetable soup. Each pot of soup takes 1 full bag of vegetables. How many pots of soup can he to make? Right. That's 5/8 times 3. Wait, when you do this, I think you just add the tops. So it's like 15/8. Yeah. Oh my god. Okay. 15. That's like 1 pot. $11, $7, $10 centimeter dollar candles stick out from the cake, an additional 5 and 4 10 centimeters. So the height of the cake and candles. Okay. 5, 16. Oh, hold on. 16 and 17 and 1/10. I think. How do I write a mixed number in here? Oh, like this. Z below. 3, 4, 6, 9, 4. Times plus 3. One-third? Wait, is that how that works? I think so. Okay, 3 friends ate. How much cake did all 3 friends eat combined? 5, 6, 7, 8, 9. Following tape diagram. 1 hole. 4, 5, 6, 7, 8, 9, 10, 11, 12. 4, 12 plus 1, 12. Oops. Plus 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. The owner of a product stand is selling bunches of grapes. Priced by the pound, she rounded each measurement to the nearest 1/8 of a pound and plotted them on a line plot below. Eighth. Okay. 1/8, 2/8, 3/8, I see. How much grapes? How much heavier is the heaviest bunch than the lightest bunch? Okay. What, that's 1 7/8. And the smallest one, 5/8. Oops.
Casper Caper 17 says the biggest challenge with these questions is reading the diagrams they supply.
I know, right? And like paying attention to what they're asking. 7/8. 5, so 1 2/8. 1 1/4. 3 halves. Wait, 3. 1/4, 2/4, 3/4, 4/4. That's 3 halves? Yeah. 1/4, 2/4. Okay. And 5/4. Well, I guess I should think about where each one's located. I mean, I think the other one would be closer down here, but you know what? Better be safe than sorry. 6. Wow, it's barely bigger. We have two fractions, 1 6 3/8, and we want to rewrite them so that they have a common denominator and whole number numerators. What number could we use for the denominator? Okay, 48. Each circle to help us find an equivalent fraction. 4 equals 2/3. Of this. Oh yeah, you said I could just subtract the whole number out of it. So that would leave 8/10. Oops. 8/10 is bigger than 1/2. Well, yeah. It was faster. Yeah, Casper, it was faster subtracting the whole number from it. 3, so 2.
Casper Caper 17 says,
Roll.
yeah, that's good.
5 3, 2. 2/5, 4/5. Subtract 2, and then you end up with 1, 5. How about this? 2, 5, 4, 3.
Casper Caper 17 says there's more tricks to go faster. You can also
Oh, God.
multiply both sides by a number is not me cases.
Not me cases. 1 3 5. Kind of
Casper
wanna
Caper 17 says some asterisk.
wait, just in case. I'm gonna do it. I don't want to start from the beginning. I don't want to start all the way from the beginning. So, well, I mean, I could still just 5 minus 32. Okay. So let's do 2 2/5. Minus 4/5. Well, I mean, at least I'll double check it again in my head. Subtract 2, this goes down to 1. Then there's 2 left. 5 minus 2, 3. Oh. Then bought different drinks for a party she was throwing. After the party, she had the following drink amounts left over: 1/5, 8/10. Which statement correctly compares the amounts of 2 leftover drinks. Pam had the soda. Where's the soda? Then water. No. Less water. Then apple juice. Yeah. Wonderful. I love this question. Easy. 4 forks on each number line. 1, 2, 3, 4. Supposed to be on here? 4, 5, 6, 7, 8. Yeah. 8. Okay, 6. Oops. Oh god. Okay, I can only draw on the top part of the screen. Crazy. Okay. 6/3, so 2, 3, 4, so 8. Also 3. Extra. Only number line. 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Wait, 5 minutes. Oh yeah. Lanes of 5 adult killer whales are shown in the table below. Lanes around to the nearest eighth of a yard. All the measurements in the line. The tick marks add dots. Click on tick marks to remove dots. Okay, 7. 7 eighths. Wait. 1/4. 2 3s, 4s, 5 8, 6 8, 7 8. 1/4. No. 3 4. 7 and 5 eighths. Wait, 4 eighths, 5 eighths. Good. 6 7 8. Two 12, 7 6, but first comparing each fraction to half and 1. Interesting. 12 is less than a half, 7 6 is less than 1. Oh. Okay, 7 6 less than 1. Step 2. weights of 11 different babies are recorded on the line plot below. Each weight would round to the nearest 1/8 pound. Each point represents a baby. 4 8, 5, 6. Heaviest. 2 A's. Sophie's dog is 8 chew toys. Annie's dog is 1/4 as many chew toys as Sophie's dog. 2. 3, 4, 5, 6, 7, 8. Yay. Okay, I have fixed 4th grade. Now I just have to fix 5th and 6th because they added new topics, which is really annoying. At least for 5th. What's 5th? Okay, this one's finished. Yeah. How many? 22. Oh my god. These all have like 20 questions. Except this one. It's annoying. It's gonna be annoying.
Casper Caper 17 says you did that test quite quickly.
Yeah, because it's just a review test. They added a new topic, so I just wanted to get the extra 10 points. Lol. Because I wanna have everything 100%. That's why. See? I gotta get everything. I gotta do all of Khan Academy. I cannot slack. Alright, okay, 600. Is this 10? Is it 10 times? 10 times 6 is 60. 100. I'm stupid. 100. Right? Okay, so 5 into 20. 24. 5 into 450. 90. 7, 6. 60. 10. 18. 20. Okay. But damn, I'm sad all these unit tests have so many questions in them. It's so unnecessary. Oh my god, 22 to 44 minutes. Estimate. Oh, these ones are gonna be annoying too, because it's like long division and stuff. But you know what? I'm gonna do it. I'm not gonna complain. Once I finish this stuff, then I can get into more interesting things where I can actually use a calculator. And that's gonna be really nice. I look forward to that. Okay. Maybe 6. 6, 7, 8, 9.
Casper Caper 17 says
Solving
I don't
it.
want to spoil the answers.
Numeric. Yeah, I'm doing it by hand because there's no calculators allowed, so if it doesn't give me a calculator, I won't use a calculator. Okay, so I assume 4 is 100. 4 is, so 8. 6 remainder 8.
Casper Caper 17 says you can do 5 asterisk 16, then add 16 and see what is left over backslash.
Wait, what? 6, 5? Well, that's basically what I did. Oh, wait, you mean 5 times 16 is fast? Well, yeah, I actually did that. I did 5 times 16 first. And then I did it 6 times 16. And saw what was left over, so. Oh, this one's an estimate. Okay. So they probably want 600 divided by 30. 60 divided by 3. I think it was 3. And it's 10, it's 30, so like 20.
Casper Caper 17 says oh I didn't see ha ha ha.
Oh, yeah. Okay, 6 seconds in 1 minute. 2 minutes. It's 12. 6 7 is 420. 6 times 7 is 42. Right? 7 times 6 is 42. Boy, these questions are annoying as hell. Okay, maybe we need to make an estimate first, so I mean not 10. 10 would be 750, so let's go 5. It's gonna be more than that. $35, 6 for 7. Wait, 35 into, oh. Oh, wait a second. Why am I multiplying? It's supposed to be long division. Oh. Okay. 75 for 20. 7 for 20, 28, 300.
Casper Caper 17 says yeah this one is pretty tough.
It's just tedious and time consuming for no reason because I don't want to use a calculator. 0. 0. Okay, I'm gonna guess 7. Oh my god. And there's not enough like screen real estate to write either, which sucks. 9, 50, 51, 52. Okay, so it's gonna be 6. I guess. 6. 30. 42, 43, 44, 45. 450. So remainder 50, I think. 46, remainder 50. I'll do it by hand, but I will check with the calculator. Because I don't want to get it wrong and do it all over again. Because it's a lot of, you know, it takes a lot of time to do this. Oh my god, I think I did it wrong. Crap. Let's do it again. Divided by 75. Wait, I'm wrong.
Casper Caper 17 says you can think for a bit. Is 50 a logical number to remain?
I don't know. Oh wait. Well, I guess if it's 75, it's divided by 75, I guess. But this is actually wrong, so what would I do? Oh wait, I wasn't supposed to bring down. Oh wait. There was a. I know what I did. Because my stuff wasn't lined up. Okay, wait. Let me do it again. This was supposed to be like over here. Because this was actually like 300. Oh wait, no. What I did bring down a 5. 5, 10, 15, 20. 1, 28, 29, 30. 300. Yeah. Oh, I did bring it down. Never mind. But then 75. Do I just not know how to do long division? Maybe that's what it is. 75 times 6 was, what was this? 30. 6, 4, 2, 3, 4, 5. Yeah, I guess I just don't know how to do long division. Wow. Because 75 times 46. Wow. Okay. I'm doing the long division wrong. $50. Oh wait, I get it. I don't know why I'm bringing down others. I'm just like not doing. You're right. I know what you're saying now. Yeah. Wait. It should just be. Wait, it goes in 50 0 times. And remainder 50. Wait, I think. $40 and 75 plus 50. Yeah. I wasn't supposed to bring down an extra 0. I don't know why that happened.
Casper Caper 17 says yeah, that makes sense.
This is a good review of long division. To be honest, I won't complain too much, since I'm obviously like doing it wrong. Sam will the same length fence each day at the end of 6 days. Fence is 54 feet long. How many feet of fence does Sam build each day? So 6 times what is 54? 6 times 9? Because 9 times 5 is 45. 9.
Casper Caper 17 says oh no, convert feet to inches.
That's not that hard. It's just times 12. It's just 12 times 9. Well, 12 times 10 is 120. So then minus 12. 120. 110. 108. Sure. Okay. I could be like, oh no. We always do that in the US. Yeah. Feet to inches. Easy. It's 12 inches in a foot.
Casper Caper 17 says how would I know? I don't use the units.
Fair. Following your model shows 97 times 35 broken into parts. The image is not drawn to scale. Okay. Of each part. What the hell? This is like so much work for one question. Like this should be one question. This should be one question. This should be one question. But no, I'm not supposed to freaking have that. Fine. Jesus Christ. Let's do it the long way.
Casper Caper 17 says with miles to kilometer it is a really stupid number.
It is though. A really stupid number. 0, 9, 18, 27. Oh. So 2,700 for A. Gotta do this the real slow way. B, 90 times 5. I don't want to get it wrong. 0. 9, 400. 450. 210. And then 35. Oh, this is just a breakdown of what 97 times 35 is. I just realized that. 90 times 30, I see. 90 times 5. Okay. 7 times 30, 7 times 5. Times 35. Wait, 97 times. Okay.
Casper Caper 17 says, I guess it didactically makes sense to teach it in that manner.
Yeah, at least for like understanding how it works. Yeah, I don't think this is like a convenient way to solve it though, so I'm not gonna like use it, but yeah. It's a cool way to show it.
Casper Caper 17 says otherwise it can be hard to figure out. You can calculate it like this.
That's true. Without seeing it like this.
Casper Caper 17 says you would do 100 asterisk 35, 105.
4, 5, 6, 2. Okay. I'm trying to calc. Oh wait, no. 2. 5, 6, 7, 8. This 4, 7, 8, 9, 10, 11, 12. No, it should be 3. 3. 3395. $2,934 times 5 using the standard algorithm. Oh yeah, I forgot that it was called the standard algorithm. Okay, so it's going to be A or B. 5, 10, 15, 16, 17. This one.
Casper Caper 17 says that is by far the easiest way to calculate it like that.
Yeah, it's the only way I was taught when I was in school too. It's the fastest way to do it. If you have like a pen and paper, you can just do it. It's quicker to do it like that. But I like the other ways too. Like I like it's cool to like learn that there's, you know, other ways of thinking about it. I guess 90. It's 5, 4. $19,700 grams of sand in a sandbox. Grams! He brings home another 6,300 grams of sand from the breach to add to his sandbox. How many kilograms of sand does Jim have in his sandbox now? Kilograms divided by 100. Oh, so you can just take the zeros off. So 197 plus 63. Yeah. 10, 16. 260. Because, I double check with the calculator. F! Are you serious? What to do? Can you not do that? What?
Casper Caper 17 says, oh no.
197. Can you seriously not add 197.63?
Casper Caper 17 says, I cannot tell you this is the test.
Yes, you can. I already got it wrong. I have to restart it from the beginning. I already got it wrong. Why can't you take off the 2 zeros?
Casper Caper 17 says, oh I see. The factor between grams and kilograms is 1000.
Oh, kilo! You stupid metric units. Are you serious? That's why. Cause one. Oh my God! No, no. So it's supposed to be like what, 26 or something? Are you? Oh my God! Kilo means 1000. Oh my God! I thought it was 100. This is. No, I would rather them just use inches and pounds and crap. Why? No. Actually, I really.
Casper Caper 17 says deci is 100.
No, I can't believe I'm doing the units test. I mean, I could just. Honestly, I could avoid it and just do the quiz because it would just give me 9 questions instead of freaking 22. Because this is a lot. I don't know if I really want to. But it's still a good review. I really probably should. I don't know. But this is like this is really irritating because it's so much work. Like they expect a 5th grader to do all 20. Think about it. Like I'm literally not a 5th grader, and this is actually like a lot of work, and they expect a kid to do this. Like this is kind of ridiculous. 22 problems. Like the way they structured this is just really unforgiving. Of course, here we go with miles and into yards.
Casper Caper 17 says kids take a year on this, remember?
Yeah, that's true, but still. I know, but it's still 5th grade though, regardless.
Casper Caper 17 says, and kids are not requires do get 100%.
Oh yeah, I'm just doing that to myself because I hate myself. You're right. Crap. But still. Okay.
Casper Caper 17
6
says, in
times
fact
8
it was virtually
is
impossible to
48.
fail in primary school.
7 times 8 is 56. 46. And 48 for 9, 51, 2. Wait. 6 times 8, 48 for 9, 51, 2. Yeah, 56. Okay, anyway. 60. 7. 7,080. That's true, but they have no idea. The people who made this have no idea how annoying this is for adults to do. Like, if you want to 100% it. And every time they add a new topic, you have to retake the unit test if you want to score all the points again. Even though, as you saw, I already did most of these anyway. I'm just having to redo it. All from scratch again. Oh my God. It's just literally one problem, but they literally made it so... It's 1 out of 22. But they made it so it's like, it's just like such a pain the way they made this.
Casper Caper 17 says,
exactly
I fervently hate online tests.
Like, they tried to make this as tedious as possible. I think it's 1,000... There's 176, so it's 10. Wait, that doesn't make sense, though. Does it? Because if it's 8 for 7,000... Wait, unless I messed up with the 8. This one has to be wrong. What did I do? 0. Oh, it just doesn't look right. No, something is obviously wrong with it. Let me just see where it is. Use a calculator just to see which part's wrong.
Casper Caper 17 says
I think it's the
scored
second thing.
76% on my study check exam, which was less than the advised 80%. However, currently I am doing just fine in my studies. The test vastly underestimated how well I did, cause it only scores the final answers.
Yeah. I'm only doing this because I hate myself. Okay, so I did the second part wrong. 1,760 times 8. I obviously didn't multiply it right. Times 8, 48, 56 plus 4 is 60, 8, 9, 10, 12, 13. Oh! I don't know why I missed this last part. 14,000.
Casper Caper 17 says I have to cook dinner now though.
Aha, good luck. Enjoy your meal. The pain of this. Four. But yeah, good luck. Oops. Me too. Six, 8, 16, 24. This 0.246. Okay, 30 goes into 900. No. Wrong division. Okay, 7, 5. $30, $45. $7. What? 3. Okay. Milliliters. So mill is 1,000. This is 14,000? Oh wait, there's a reference sheet. 1 liter is 1,000, so 14,000 plus 14,000, 10,500, 23,500. Oh, come on, just because of like... Oh, wait, no. I'm wrong? Where do I hit this? That is milliliters. 1 liter, 14,000. Did Tony have left over? Oh, I just didn't read it. Maybe I should just do the quiz thing instead. Oh, so sad. These are such a pain to do. Honestly. I'm watching videos here. Computer science. Science topics include visual thinking. C. Course well. Oh, that's so loud.
Hello, world. This is CS50, Harvard University's introduction to the intellectual enterprises of computer science and the arts of programming. CS50 is
Lowy Chip says, have you mastered maths yet?
And implement solutions.
Bruh. No. There's literally so much of math. Are you kidding?
Hello, world.
And then they added a bunch of new courses into the lower levels, and I have to go back and complete all the little gaps I'm missing. And it's literally taking forever. So I'm gonna like go back and forth between doing that and watching videos in this course, so I have some
This is CS
time to relax.
Hello, world. This is CS50, Harvard University's introduction to the intellectual enterprises of computer science and the arts of programming. CS50 is a course that teaches you how to design and implement solutions to problems. But more than that, it teaches you how to think more critically, more methodically, more computationally. Now, computer science itself isn't really about computers, or programming for that matter, but information. And we'll first learn how to program with Scratch, a graphical programming language via which we'll explore some fundamental programming constructs by dragging and dropping puzzle pieces. We'll then quickly transition to a more traditional text-based language called C that's actually been around for quite a while, and as such, it doesn't come with all that many features out of the box, so to speak. We'll then transition to Python, a more modern language that you can use not only to write programs, but also web applications using CSS and HTML. The problems you'll encounter and solve along the way will come from the world of cryptography, finance, music, and beyond. And always there to help you too, albeit virtually, will be Zamila and Doug and classmates from around the world who are learning alongside you. But the most fulfilling experience ahead is to design and implement an idea of your own by way of the course's final project. Indeed, what ultimately matters in this course is not so much where you end up relative to your classmates, but where you end up relative to yourself when you began. This is CS50.
Wait, I hope that's not like copyright music now that I think about it. 11 weeks. Where's the 11th week? Oh wait, it starts on week 0. Oh my god. Watch lecture. Watch section. Watch shorts. Wow. Okay, let's make problem set. Way. Skip, skip, skip. Okay, let me go back and do a few of these real quick. This is so tedious. Okay, I'm using like 600, round down to 300. Now 18. And then, 2, 3, 4. 180,000. Right? I'm just gonna do this one. This one's a pain to do. Well, I mean, okay. Can I do this without writing anything down? 70. 0. 8, 0, 0. Okay. B. D. Wait. Let's bring it back for. Okay, let me go look at this. Okay, 26. Oh, what is he 26 times 74? Okay, yeah. I think I'll just watch the video. I'm not gonna do any of the exercises with Scratch, probably. Presentation unary. Never heard of that. Binary. Decimal. Unicode. Running time. Pseudocode. Oops. Events. Threads. Cool. What is audio? Oh, 454. It's just the lectures audio.
The binary.
Yeah. Is it the same thing? Oh, it's just the YouTube video again. What's this? I'll probably still take a look at the problem sets. Yeah. So I guess the week 0 only has this one video. Oh yeah, with no shorts or... What do they also call them? Lecture, short. Wasn't there another thing? Oh. Like it said watch lecture shorts and then there was... Oh, sections. Oh. Probably this. I'm not sure what that is. What the section's about. Maybe it's just the lecture broken into sections? Yeah. Okay. When did it start? It's kind of cool. This course has been updated. What the?
Hello world, this is CS50. Harvard University's Introduction to the Intellectual Enterprises of Computer Science and the Art of Programming. Woof woof. I'm sorry, Dave.
Oh my god, what is that, an ad? So much theatrics. Here? There. How long does this go on before the actual lecture? Okay. Jesus.
This is CS50, Harvard University's Introduction to Intellectual Enterprises of Computer Science and the Art of Programming. And this is Spot. And our thanks to our friends at 3D Cowboys for bringing him by class today. Perhaps a round of applause for our special Professor Gav. My name is David Malin, and I actually took this class, CS50, myself some years ago, but I almost didn't. And I didn't because when I got to campus as a first year, I really gravitated toward things already familiar, things with which I was already comfortable, specifically government. And I came in here thinking I was going to major or concentrate in government. And it was only once I got to sophomore year, fall semester, that some friends of mine were coming to this class called CS50 that was very much to beware at the time, in that it was an unfamiliar field to so many of us, myself included. But I sort of got up the nerve to go over the threshold, sit in on the first class, to shop it, so to speak, and I was hooked. I found that, like, homework was for the first time fun, and this was after having enrolled only because the professor let me enroll pass-fail, or sat on sat, because I didn't really think I could even cut it. But fast forward to like 5 Mondays later in the semester, I actually switched to a letter grade, deciding, wow, this is actually something for me. And I say this because computer science, what I didn't realize about it at the time, really is this very general purpose way of thinking and way of solving problems. And even if this is the only CS class you ever take, even if this is the only formal training you have in programming as a practical skill, it's just so darn applicable to so many other fields, the arts, humanities, social sciences, natural sciences, and beyond, and certainly within the STEM fields themselves. That said, it's going to often feel a little something like this. This is from our friends at MIT down the road, which is one of their hacks, whereby they connected a fire hydrant to a drinking fountain with a little sign up there that says, getting an education from MIT is like drinking from a fire hose, which is to say that it's going to feel quite often in this class too that there's just a lot of information and you can't possibly absorb it all. But realize that's sort of to be expected, especially in an introductory class. The whole point is for so much of it to feel new, but with practice, with time, with years even, looking back, will you get all the more comfortable with the material. But you're not meant to feel comfortable along the way, and so let me encourage you, invite you, expect you to get comfortable feeling uncomfortable along the way, whether you have or have not prior computer science or programming experience. Now, back in my day, the class's syllabus was a little bit different, and really when I and all of my classmates exited the class, we would say to friends that we learned how to program in C, which is a language that we ourselves will still learn in this class, but that was it for languages. But nowadays, as you'll see, we'll explore not just this older language called C, but a more modern language called Python that's very much in vogue for data science and web applications and much more. But we'll also introduce you along the way to another language called SQL or SQL, which is specifically for databases. And SQL is a different type of programming language that's just going to give you different ways of solving problems, different building blocks with which to express problems you want to solve. We'll introduce you toward the end of the semester yet another language, JavaScript, often used with markup languages called HTML and CSS, with which maybe you have some experience if you've made websites, but we'll do this because so many of today's actual real-world software is web-based, or it's phone-based, mobile-based, but even then it's using these same languages like JavaScript. And so by the end of CS50 in particular, you won't know how to program in X or Y or Z per se, but period, you'll learn how to program. And indeed, among the goals of this class is to equip you with enough of a set of concepts, enough practical skills and experience that after CS50, again, if you never take another CS class, you can teach yourself new languages, and you won't have been reliant on a class to indeed introduce you to each and one of those ideas. And what are we going to do then in this class, and really what are we going to start doing today? Well, we're going to learn how to solve problems, and that's really what computer science is all about. We'll very specifically today knock off a few to-dos. We'll learn how to represent simple things like numbers. We'll learn how to represent letters of an alphabet like English. We'll learn how to represent colors, red, green, blue, and everything in between. We'll learn how to represent more interestingly, full-fledged images that you might see on the web or your phone. We'll talk about representing videos and even audio files. So by the end of today alone, you will exit here with a newfound mental model for how you can represent all of today's media and multimedia that we sort of take for granted and use most every day. But
that's cool. Okay. I like the course update. Oh wait, 17. 16, 36. Cool. 6. Oh wait. 7. Minutes, seconds. 15 seconds? 15, 30. Not sure how that's so loud. 4. 8, 6, 10. Okay, 3.5 to double check. Okay, 740. $74,000. That's 700 divided by 70. 10. Susan started her homework at 1:59 p.m. Finished her homework 96 minutes later. Susan had volleyball practice at 4 p.m. Finishing her homework in the beginning of volleyball practice, of course. Okay, well, at 2 p.m., there was 95 minutes. So at 3 p.m., it was minus 60, 35 minutes. Oh, so 3:35. 60. Minus 30 is 30 minutes. Minus 5, 25 minutes. Don starts to use the standard algorithm to solve for 18 times 5. 5 times 8 is 40. 4. 11 divided by 101. Don't you have to like move the decimal over like this or something? Like, but this makes sense. It's 11,000. 1.01. $110. Okay, no. One. What's the process you do for this? Oh wait. 0.01. Oh. Times 1,000. Oh yeah, 1,100. I think. Oh wait, I think I was just supposed to know that because the decimal. One. Wait, I'm trying to think about this. I'm pretty sure this is the right answer, but yeah, because you multiply this. Yeah. Of course. Division. Oops, it's probably 3. Okay, so 3. 22. It's 8, 9, 10, 11, 12. 9. Oh, okay. Like 5. 5 remainder 9. Track 35. Yeah. Okay. Back to more CS50.
We'll also focus today, ultimately, on how to write algorithms, like step-by-step instructions for solving some problem, specifically how to write, granted, and use most every day. But we'll also focus today, ultimately, on how to write algorithms, like step-by-step instructions for solving some problem, specifically implementing algorithms with code. And that's what we'll find. An algorithm is just something you can express in English or any human language, but code is a translation of that to presumably the zeros and ones that you've probably heard is all that computers ultimately speak. And if you're feeling like that's a lot for today, if you're feeling like that's a lot for the whole semester, realize and take comfort in knowing that 2/3 of you have never taken a CS course before. So even if you think, like I did all those years ago, that surely my friends, the kids I didn't even know in the class, must know more than I've been programming since they were 6 years old, that's just not the case. You're in very much good company. And within the class will you find different tracks by way of the homework assignments called problem sets, by way of the sections or recitations. There'll be different tracks for those of you less comfortable, more comfortable, somewhere in between. And if you really don't know why you are here today, we'll even have sections for those least comfortable where you just don't necessarily feel ready to dive into CS or maybe STEM more generally, but we'll get you there by way of the course's support structure. And it's very much grounded in this mindset. What ultimately matters in this class is not so much where you end up relative to your classmates, but where you end up relative to yourself when you began. So whether you have or have not prior programming or CS experience, it's not going to matter when it comes to evaluation, when it comes to the output, be it a grade or a satisfactory mark or the like. It's going to depend on really where you are today in this, what we call week 0, versus the very end of the semester, when you'll have built something grand of your very own in software. But CS50 is also characterized fairly uniquely by its community, its culture, and along the way you'll see that your experience is punctuated by a lot of social and academic events alike. CS50 lunches, most every Friday we'll gather at a nearby restaurant called Chang Shou where we'll have Chinese lunch together, and as many of you as might want to attend that week will be able to join us, sit down and chat casually with me, the course's teaching staff, friends of ours, alumni from industry as well. CS50 Puzzle Day coming up this weekend will be an opportunity, even if you have no prior CS experience, just to solve problems. Not jigsaw puzzles, but puzzles in the logical sense. We'll hand you a packet of puzzles, logic problems or riddles or the like, that you as teams can solve together. And at the very end, we'll walk you through, and along the way, there'll be not only these puzzles, but pizza and prizes and so much more as well. Toward the end of the semester, we'll have a CS50 hackathon, whereby we'll get together around 7 p.m. At the start of reading period, and we'll finish up around 7 a.m. the next morning, and it'll be this opportunity to really bond with your classmates, your project partners, if you work in a team, on your very own final project, which is meant to be a capstone of the course, something you build yourselves that we don't hand you a specification for, but it's sort of your final offboarding, so that when you exit CS50, you don't need CS50 anymore. You don't need me, you don't need your TF, you can actually write code and solve problems on your own. So this pictured here is one of our past photos from earlier in the evening. Things get a little quieter as we then, around 5 a.m., drive anyone who's still awake and energetic to a nearby IHOP for pancakes around then. But here is how most of the evenings tend to end for at least some of your classmates prior. But at the very end of the class is the so-called CS50 Fair, an exhibition of all of your final projects for friends, faculty, students, and staff across campus, whereby you'll be invited to a space like this. Bring your laptop, bring your phone, whatever it is you have built and created, and we'll just show it off for a bit of the afternoon, complete with music and friends from industry and candy and all what makes gathering together at term's end fun. And you'll wear, ultimately, very proudly, we hope, your very own I took CS50, stating very matter-of-factly what I did some years ago, that indeed this was a course I myself took. So today, let's focus then on computer science. Like, what is it? Well, it's really like the study of information, but really it's more specifically about solving problems using certain ideas and techniques, all of which you'll exit the course with. So as such, problem solving is a goal that we'll approach by way of something called computational thinking. So computational thinking, you can kind of oversimplistically think about it as like thinking like a computer, but it's really the application of ideas that we'll dive into today and we'll finish some weeks from now that you can apply to problems from this field or most any other, but in a computational, that is a very methodical, very careful way. And that's what CS really did for me and does for a lot of people. It helps kind of clean up your thought processes. Even if you go off into the real world and do nothing in tech, you have an ability after classes like this to express yourself a little more correctly, more precisely, and generally having better command of your own ideas and your language. So what's problem solving? Let me propose that this is it. Like, this is as simple as we can make today's goals and the semester's goals. Problems to be solved look like this. You've got some input, the problem to be solved. You've got a goal being the output, like the solution there too. And then somewhere in the middle is the secret sauce where we'll spend the next several weeks figuring out how we can convert these inputs to outputs. But before we can do that, we all just kind of have to agree on how to represent these inputs and outputs, whether it's with English or really any type of language. But as I spoiled earlier, you probably came in here already with a general sense that, yeah, computers somehow only speak or know zeros and ones, the so-called binary system. But that's just one way of representing information. Even simpler than binary is unary. So if you've ever, at this age or any prior age, sort of counted on your fingers, this is unary notation, whereby each of your digits, your fingers, literally represent some piece of information, taking attendance like 1, 2, 3, 4, 5. But on your one human hand, how high can you count in this unary notation? 5, I'm hearing 5. 6, I heard 1, 6. But I'm going to go further and say the answer, if you're clever about it, is actually 14? Not quite 40. You overbid, but 31 is as high as I can actually count. And that's because if I actually, and if you're thinking this is weirdly painful now, like it will be, but this is my hand representing the number 0. Normally in unary, this is 1, 2, 3, 4, 5, of course, obviously. But what if I take into account the order in which I'm putting my fingers up and down? So maybe this is still 0, maybe this is still 1, but maybe this is now 2, where it's just the single second finger up, not 2 of them total. Maybe this is now 3. Maybe this is now often offensive with just the middle finger up. This is now 5. This is now 6. This is now 7. And my hand just hurts too much if I try to count higher than 7. But theoretically, because each of my fingers can be down or up, and I've got 5 of them, that's actually 32 possible permutations up and down. But wait a minute, we said 31. But if you start at 0, you kind of have to subtract 1 from the biggest possible value. So this is to say, you and I have been using unary because it's just simple and it gets the job done. But if we just think about representation using unary, you kind of have to subtract 1 from the biggest possible value. So this is 31. But if you start at 0, you kind of have to subtract 1 from the biggest possible value. So this is to say, you and I have been using unary because it's just simple and it gets the job done. But if we just think about representation a little more cleverly, we can do exactly what computers do, using not what mathematicians call base 1, where the finger's either there or it's not, but base 2. And in base 2, we just need 2 digits at our disposal. And we could call these digits 1 and 2, A and B, black or white. Like, we just need 2 words to describe 2 pieces of information. Computers keep it simple, and just like we humans start counting 0, 1, 2, 3 on up, computers use 0 and 1, and that's it. But that's by convention. But why do they do that? Well, it turns out when you use base 2, otherwise known as binary, well, it just maps really readily to the real world, because at the end of the day, what do we all do if you've got a laptop or a phone or any device? Like, you plug it into the wall because it needs electricity at some point. And what if you have electricity or not? Well, there's your sort of 2 possible values. Either it's there or it's not. And because computers are electrical devices, this is why binary is just useful. It's nice and simple. Either electricity's there or it's not. So when you plug this device in and you've got all these electrons or whatever flowing, maybe if we just kind of hang on to some of that electricity, we can represent what we'll call a 1. And maybe if we let it dissipate or go away, that's a 0. So on and off maps very readily to this idea of just zeros and ones. And if you
18 by 6. Katie weighed 8 pounds 1 ounce. Ounces. Pounds 1 ounce. Oh, in ounces. I think 16 ounces in a pound. Okay, so so 96 plus 105. Right, 16. 8. 129. Eight. 5. 24. If I'm to check 3 days, how many meters? So in total. Kilometers 1,000, so 13,000 meters. Are you serious? What did I do? 3 days. I didn't see that. What, 39? Oh my god. Sorry, this is too much. Asking 22 questions. 4/5 distance to the hole. 6 stroke. The ball traveled 700 meters. Went to the hole. Sucks. Travel 4/5 distance to the hole. Kilometers from the hole of my arm when he started. So I guess this is 1/5. Wait, so 79 times 5? Okay, it says kilometers. But still. 35, 6, 7, 3, 39. I think 395 meters. So kilometers. Like 0.00395 kilometers or something. Oh wait. It's 0.000. Wait, 395. 1, 2, 3. Or just 300.395. Doesn't even matter if I get it wrong because I guess 0.395. I was gonna say, because 1.6. Because I'm still at the very beginning now. After getting that long. Yeah, I guess I'll try to go to 500. Try to go to 7. Boost made 24 clicks on the made to pick lemon bee clip 6 pictures. In each picture. 4. Two. Was it 2 quarts in a pint? 2. 1 quart is 2 pints. 8 pints. It's like 0, 0, 0, 0. I think 300 times 400. I'm divide it by 20. We're going to divide it by 10. It's 80 to 40. Alright, going up to this lecture.
You've ever thought of this now as binary digits, bi implying 2, 0 and 1. Well, if you've ever heard this term now, bit, it just means binary digit. A single bit is just a 0 or 1, but we could have called these things anything we want. Now, how does this map to be clear to the real world? Well, we can't see the tiny little switches inside of our Macs, PCs, and our phones that are actually turning the electricity on or off, storing electricity or not, but they're called transistors. They've got like millions of them in today's hardware, and they're just on or off like a switch or a light bulb. So for instance, if there's no electricity, the switch is off, we would call this, by convention, a 0. If, though, you throw the switch and it actually turns on, we would call this an on, exactly a 1. We could have reversed it, but this is just the way the world decided to standardize. And that's it. So you've either got something on or off, a 1 or 0, and this then is this thing we know now as a binary digit or bit. So once we've got these values, what about how can we go about perhaps representing things? Well, you know what, it turns out we got like a lot of light bulbs right here. Let me grab, excuse me, Spot. Let me grab the little music stand here. Let me borrow a couple of these bulbs and see if we can't make clearer than my hand alone what's going on here. So I'm going to go ahead and grab 2 of these, and I'll just put them here, and I can turn these things on or off now. So if I've got 2 bits, 2 switches, 2 transistors, if you will, well, if I go ahead and turn on this one, I'm representing what number in binary, perhaps? So just 1. Now, if I'm using unary, I would turn this one on and be done with it, and that's 2. But not in binary. Binary, it's the permutations. Which ones are on and off that matters. So what now am I representing here, perhaps? 2. So this is when I put like my single pointer finger up, but here perhaps. Which ones are on and off that matters. So what now? Binary, it's the permutations. Which ones are on and off that matters. So what now am I representing here, perhaps? 2. So this is when I put like my single pointer finger up, but then when I did this in my human hand, this was like representing the number 3. How do I represent the number 4? Yeah, like I need kind of another light bulb, so I need more hardware, so to speak. So if I leave this one, if I turn this one on, this one off, now I have the number 4. And someone tell me, saying the words on and on and on, or on or off or on, using combinations of on, off, and on and off, how do I represent 5 from your left to your right? How about over here? On, off, on, I heard, and that's exactly right. And how do I represent maybe 6 over here? Off, on, not quite from left to right. Okay, so from right to left. So I think we leave this one on. This one I'm going to claim represents now 6 and 7. I'm just going to, it's actually going to be on, on. Now, if you're sort of wondering, like, where are these people coming up with these combinations, there's actually a system here. It's actually kind of hard for me to do it backwards, but it turns out there's actually a system that's not all that unfamiliar. In fact, let me propose this. Let me propose that we consider what you and I all learned in grade school, which was something like the base 10 system. 10 meaning that you use 10 different digits, not 2, 10. So like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the base 10 system, otherwise known as decimal, dec implying 10. So that's what you and I use every day. Well, let's think about how we represent numbers in decimal in the normal human way. Well, here's a number. It's what number, of course? 123. So we all just have an intuition for that, obviously, but it's not necessarily 123. You're just assigning meaning to the positions of these digits. This is really the pattern 1, 2, 3. But you immediately jump mathematically to 123. But why? Well, odds are in grade school you learned that the rightmost digit is the ones place, or the ones column. This is the tens place, or the tens column. This is the hundreds place. And so why is this relevant? Well, this is like doing 100 times 1 plus 10 times 2 plus 1 times 3. Or if we multiply that out, 100 plus 20 plus 3, ergo the number now that we just take for granted is 123. But that's in base 10.
Wait, he was talking about unary earlier. What's that look like? Oh, that's it. So, why did he say there's 31 presentations with unary? Maybe he meant binary. Oh, this is probably what he meant. Like if you convert it, but the position matters, then he subtracted 1 because or something. He said 31. That's probably what he meant.
The so-called decimal system, whereby each of these digits is in a different column. And those columns are, again, ones, place, tens, hundreds, if we keep going, 1,000, 10,000, and so forth. But where did these come from? Well, here's the base. If you remember exponents and all of that, this is just 10 to the 0, 10 to the 1, 10 to the 2 ad infinitum. And so now, what if we just change the base from 10, 0 through 9, to just 2 digits, 0 and 1? Well, now the math is sort of fundamentally the same, but it's 2 to the 0, 2 to the 1, 2 to the 2, which gives us the 1's place, 2's place, and 4's place. Now, why is this relevant? If you've got 3 light bulbs or 3 bits that are off, 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 what have I done? 4 times 0 plus 2 times 0 plus 1 times 0 is obviously the number you and I know in decimal as 0. This, though, represents the number you and I know as, this represents 3, 4, and just to be clear, this is why when I grabbed the additional light bulb, we claimed that this now was 4, because we had on, off, off, on, off, off. This now is 5, this now is 6, this now is 7, and if I wanted to count higher, what would the pattern of zeros and ones be for the number 8? 1, 0, 0, 0. So we just need more hardware, more bits. So it wasn't arbitrary, even if it was non-obvious, what I was actually doing with turning these light bulbs on and off. It was not 0, 0.
Oh,
so we just need more hardware, more bits. So it wasn't arbitrary, even if it was non-obvious, what I was actually doing with turning these light bulbs on and off. Now, it turns out here we are talking about how to represent information like numbers, but we could also use bits, zeros and ones, light bulbs, to represent instructions as well. Because at the end of the day, like, that's kind of all computers do. They kind of process data, information of some sort, whether it's files or numbers or images or videos or the like, and you do things with those files. Like, you open them, you print them, you edit them, and the like. So there's this notion of instructions, like what the computer can actually do. And I bet we could come up with some kind of pattern of zeros and ones, or equivalently, light bulbs that tell even Spot what to do. Maybe go up or down or left or right. And it could certainly do this autonomously by using various sensors. We, to keep things safe today, are using Wi-Fi and sending Spot these very instructions. But what's happening wirelessly with our friend Andrew here is essentially he's sending Spot instructions just encoded wirelessly somehow as patterns of zeros and ones. And the folks at Boston Dynamics who built this robot programmed Spot to recognize certain patterns as meaning up, a certain pattern as meaning down, left, right, and any number of other things. So in fact...
Wait, what's that sound? That was weird.
Spot, come on over here if you could. Left, right, and any number of other things. So in fact, Spot, come on over here. Pattern is meaning down, left, right, and any number of other things. So in fact, Spot, come on over here if you could. Come on. Okay. So Spot, for instance, may very well have a pattern of zeros and ones that represents shake. Shake Spot. So he could do that. And any number of other movements as well. And maybe, especially with sensors here and also a little human help over here for today, what if we went ahead and did something, maybe ask Spot some questions. So let's go ahead and we'll start simple. Spot, here we have some bits. Off, off,
Ristolo
on.
says
Spot.
doggy.
Oh, doggy, I know, right? I guess the updated CS50 course, they're doing like a collab with Boston Dynamic. It's totally unexpected, but you know, I dig it. It's cool. But it's cute. Yeah, doggy. Doggy. Cuter than any actual dog, right? I'd rather have a Spot than any other dog.
What? Okay, Spot. What is this representing? Off, off, on. Correct? I think so. Kind of like very horse-like. Okay, thank you. All right, so a round of applause for Spot here. All right. So Spot.
Wait, what did it even answer? Just like tap.
All right, so. Correct? I think so. Off, off, on. Correct? I think so. Kind of like very horse.
I didn't even understand what its response
thank you.
was.
All right, so a round of applause for Spot here. All right. So Spot, what if we we'll turn that one off here. How about turn this one on? So it's off, on, off. Spot, what's this number? Is that correct?
Oh, it probably just like tapped its foot like 4 times or something.
Nice. Okay. How about one final flourish? How about Spot? Instead of off, on, off, let's go ahead and do off, on, on. So think in your mind's eye what the answer should be. All right, Spot, off, on. Okay, and a round of applause for Spot as well. So this is to say, no matter how...
Okay, back to this. Without getting anything wrong. I think you just add an extra 0. Okay, I was gonna cry if that was wrong. This 20? Wait, no. 3, 30. Okay, just going 6. It's wrong.
Ristamo says, you know what, I'm tired of coding for 5 years. I think in the 8 years I just want to be farmer. I think farmer it's my dream job, seems good.
Really? I think farming sounds fun. What language do you use? I was trying to solve some like simple problems earlier and stuff on Exercism, but then I just got like tired, so I started watching CS50 videos. Oh, cool! Oh, nice. Didn't they? I'm trying to remember. What did Apple do? Didn't they? Before Swift, didn't they use another language? That was like their main one for like iOS apps and stuff? Or my Objective-C or something? Yeah. Did you use that back in the day too?
Ristamo says Objective-C.
Have you heard? Oh, hi, Sigma. What do you mean? What? I'm taking a quick break from watching CS50 lectures. I'm going back and forth between this and CS50 because I want to 100% all of Khan Academy. Because why not? Sigma's like, what the? Oh, I see. You haven't. Yeah. Have you heard of? Wait, what is it called? If I ever learn a language for like mobile app development, I want to learn oh my god, I can't remember its name. It's the one, it works.
Sigma says 5th grade math is something I didn't think I'd see on Twitch, lol.
Lol. Well, actually, technically, I just finished 6th grade math. I just 100%ed it like last stream, but the problem is that I didn't realize Khan Academy added a bunch of new lessons because, you know, they keep updating their courses. So now I have to go back and 100% the old ones. So yeah, because I gotta get 100% completion because my state has horrible math education. So this is how I make up for.
Burn Sigma says, are you collecting achievements for math?
Yes, in my own way, I guess. Because I have to 100%, I gotta get every question right. So if I get one question wrong on this quiz, which has already happened multiple times, it's back to question number 1. So that's why I'm jumping back and forth between the CS50 lectures and this, because I just get so tired of the tedium of these questions.
Says, oh God.
Yeah, I make stupid mistakes, like I forget to add an extra 1, or I forget a decimal point, and then bam, it's back to question number 1 all over again. Rage quit.
Says also Big Duck.
Big Duck and Doggy. Where's the doggy?
How fancy! Thank you,
Oh wait,
Spot.
that person's head is in the way. See, look, right?
How fancy today.
Doggy. Right there in the corner.
Is
Doggy.
hardware or software is. It really just boils down to representing information and instructions, and computers and phones and the like really are just operating on those same.
Doggy. So cute. 6. Okay. I'm at least gonna finish to question number 12. Hopefully I don't get one of these wrong. Expression answer is a decimal. Okay, and if it doesn't give me a calculator, I won't use a calculator, I swear. Because I hate myself. I never
says it does have the dog in it.
Is it sad if I never memorized my times tables for 12? I know, right? Doggy. I was not expecting to. I didn't realize they had updated CS50, but and like, you know, re-recorded all the lectures and everything. But I had no idea they were doing this like collab with Boston Dynamics. It's crazy. And then ducks everywhere. Like, is this like a Harvard thing? Are they just like obsessed with ducks? I don't know. Okay, 10, 5, 6. Okay. 63, 30, decimal. Wait. What, and 12 goes into that, like, 2 times? 24, 6, 0, 5. So 5.25. I think, but I'm gonna double check on the calculator because I don't want to start from question number 1 again for the 50th time. I just don't feel like it. Nope. Okay, so 10.
Fernov Sigma says that is indeed correct.
Thank you. 700. Do you program Sigma? Or do the maths? Okay. I will just keep watching CS. 50 for now. I need to not get too tired of the math. Because otherwise I'm going to make another stupid mistake. I'm going to have to start from question number 1. I think it's better for these ones, these boring questions, to do like 2 at once. And then just do something more interesting.
Sigma says, I mean, I did it once in my life, yes.
Or once in my life, that's relatable. So for me, well, I'm kind of just trying to relearn because there were times where like I kind of dabbled in programming, but the thing is I always like kept quitting because it's hard and there's a lot to learn. So I never really made it past the beginner stage of any language I've tried. I don't have to. I feel you, but calculus.
Says, I don't want to touch calculus. If
Calculus is in Khan Academy, so eventually I have to 100% all of math, so I will get there one day. One day. But I honestly don't feel like I want to go past calculus. I don't think I need to. You just, especially for computer science, all you need is like what? Linear algebra and stuff. Mainly that.
Ristamo says, so you not take a deep dive for one language.
Yeah, well, I've tried, but the thing is I haven't went far. That's the point. In the past, I focused on one language at a time. But if you just, you know, quit early on and you don't keep going, you know, that's the end of it. So I kind of want to just improve. The main language I want to improve at, if I can pick one right now, is C#.
Fernov Sigma says just need the time, I guess.
The time, exactly. And general programming concepts. And that's what I'm doing right now. Instead of just focusing so much on syntax, I really need to get better at thinking like a programmer. And, you know, that's also why I'm doing math too. Because computer science is just applied mathematics. Which is also my weakest subject too. Like, you know, math, science, thinking logically, that kind of thing. Weak subject. So, yeah. I have a lot of foundations to improve, but I do want to focus on C# eventually, because the Unity game engine. That's the reason I want to make games.
Fernov Sigma says, I think you have to learn to learn.
To learn. General programming is bad for you. Lol.
Pieces of information, whether we're just operating information and instructions, and computers and phones and the like really are just operating on those same pieces of information, whether implemented in zeros and ones or with really anything else. All right, so where can we take this once we have this agreed upon system for representing information? Well, it turns out that using
like, I kind of wonder this whole lecture. I've been wondering, like, what's the point of this bowl of stress balls? Like, is he gonna like throw these into the audience?
Fern of Sigma says I feel so lost.
Lost. I don't know how long their lectures are.
CS50 have 50 hours lecture?
But each lecture is like about 2 hours, and there's 12 or something. 11, including counting week 0. And it's just probably like 24, 25 hours, maybe 26 worth of just the lectures. And then there's a bunch of assignments, and I'm actually going to do them. Except for maybe the Scratch ones. I might skip the Scratch. Or if I do it, maybe I won't use Scratch. Maybe I'll use, like, try to use Python or C# or something. But I'm still going to watch all the things, just for the theory. Just to make sure I cover any bases that I missed.
3-bit representing.
And also, it's just kind of, like, chill and relaxing to watch this. And there's a doggy, so that's cool.
Information. Once we have this agreed upon system for representing information, well, it turns out that using 3 bits, 3 zeros and ones at a time, isn't actually all that useful. And you and I, even in conversation, don't often say the word bit. We say the word byte. And what is a byte, if familiar? Yeah. So it's just 8 bits. It's just a more useful unit of measure, and it happens to be a power of 2 to the third, which just makes math.
Because if you jump to another language, you need to learn new syntax and read new documentation. It's wasting time.
For people who are like experienced programmers, it's really easy for them to do that though. Because a lot of it the logic remains the same. And a lot of languages share similarities. I mean, I'm not a good programmer, so I can't do that. But I want to develop those kinds of, that strong foundation so that I can work with whatever language I might need.
Fern of Sigma says, huh.
Workout full unit of familiar. Yeah. So it's just 8 bits. It's just a more useful unit of measure, and it happens to be a power of 2 to the third, which just makes math work out cleanly. But it's just a convention.
Fern of Sigma says, how you mean while learning?
2 to the third. 2 times 2 is 4, 4 times 2 is 8. Okay, that makes sense. Yeah, well, learning is probably not too good to jump around too much. But, at the beginning. But the basics are still the basics.
I'm 5 years code and still need Google for some task or code. I don't know everything LUL.
I think that never goes away. That's just gonna be there for literally everyone. Like, I think the joke was being a programmer is just being a professional Googler. Yay. But I do gotta get used to that kind of thing. I gotta get used to Googling. I gotta get used to looking at API. I gotta get used to things not working the way they're supposed to be. Instead of quitting, that's the thing. Because it's easy to quit
says yes.
And get frustrated. And I'll still get frustrated, but the point is, like, I need to not quit. I need to keep looking up things and looking for solutions. Yeah. Learning to problem solve.
To have more of 2 to the third, which just makes math work out cleanly. But it's just a convention to have more interesting units of measure than individual bits. So a byte is 8 bits. So for instance, this represents using 8
Sigma
bits,
says reading
8 light bulbs,
documentation is
the
something
number you and
have
I
to
know
get
is...
used to after all.
Yeah, you're right. And everyone tells me that too. It's super important. Those are all like the kinds of reasons why I never stuck with programming, because I wasn't able to get used to the work, the flow. You gotta look things up, you gotta read API, you gotta problem solve. Things aren't gonna work perfectly, because if you're not used to doing all that, it's really frustrating.
This representing units of measure than individual bits. So a byte is 8 bits. So for instance, this represents, using 8 bits, 8 light bulbs, the number you and I know is 0. And this byte of all 1 bit, now you got to do some quick math, represents what number?
Quick math, okay. Well, I'm not going to look at the other columns, but what? 2, 4, 8, 16... Oh lord. It goes 32? 64. I think 128. And then you add the other ones, but I don't want to do the other ones.
Instead. So it's all ones, 8 of them total. How about over here on the end? So it's indeed 255. Now that's not kind of math that you need to do in your head for a class like this, but you could. This is the ones place, 2s, 4s, 8, 16, 32, 64, 128. And because they're all 1, you just have to add up all of those columns values. And you get 255.
I just didn't want to
But a little mental trick, too, is all of those columns values. And you get 255. But a little mental trick, too, is that if you've got 8 bits, and each of them can be 2 possible values, 0 or 1, that's like 2 possibilities here, times 2, times 2, times 2, times 2, 8 times. So that's 2 to the 8th. So that is maybe a little easier to do. That's 256, or easier in the sense that you get used to seeing these numbers in CS. That's 256, but wait a minute. How do I reconcile this with your 255? Because you start at 0. So you sort of lose 1 on the high end because we started counting and representing the number like 0. All right. Questions on how we've represented just numbers, or for instance, instructions to spot thus far? Any questions on binary, unary, to spot thus far?
To spar?
Numbers, or for instance, instructions to spot thus far.
What?
Ristimo says, okay.
Oh, Spot! The doggy!
Bye-bye 3.
Alright, bye-bye! I didn't even realize Automa held that.
Any questions on binary, unary, on how we've represented just numbers, or for instance, instructions to spot thus far? Any questions on binary, unary, or the like? No? All right, so seeing none, let's let things escalate a bit. So how do you represent letters? Because obviously this makes our devices more useful, whether it's in English or any other human language. How could we go about representing the letter A, for instance, if at the end of the day, all our computers, all our phones have access to is electricity, or equivalently, switches, or metaphorically, tiny little light bulbs inside of them that can be on and off. That's it. There's no more building blocks to give you. How could we represent something like the letter A? Yeah, how about here? Yeah. Perfect. So we could just assign every letter a number. And we could do this super simply. Like maybe 0 is A and 1 is B. Or maybe 1 is A and 2 is B. It doesn't really matter so long as we all agree. And we all use the same types of computers in some sense ultimately. Well, for various reasons, the humans that designed this system, they went with the number 65. So nowadays, anytime your computer is showing you the capital letter A on the screen, underneath the hood, so to speak, it's actually storing a pattern of 0s and 1s that represents the number 65. And it tends to use 7 bits or typically 8 bits total, even if it doesn't need all of those bits in total. So how do we get there? Well, here, for instance, is that same pattern. Here is that pattern of bits that represents 65. And why? Well, quick check here. This is the 1s place, 2s, 4s, 8s, 16, 32, 64's place. Okay, so 64 plus 1 gives me 65. So that is to say, here's how a computer, using some light switches, so to speak, would represent the number 65. And our Macs, our PCs, our phones just all know this. So whenever they see that in their memory, so to speak, they show a capital letter A on the screen. So that's it. That's a system known as ASCII, the American Standard Code for Information Interchange, and the A.
I didn't realize that's what it stood for. American. Say system code?
That's a system known as
Standard
ASCII,
code.
the American Standard Code for Information Interchange. And the A is actually operative there because we're only talking thus far about English letters in our alphabet. And in fact, I claimed a moment ago that we only use 7, maybe 8 bits to represent letters of an alphabet. So just to come back to you, if I may, how many possible letters of the alphabet how many possible letters of any alphabet could we represent with 8 bits? 256, the numbers 0 through 255. Now that's more than enough for English because we've got A through Z, uppercase, lowercase, a bunch of numbers, a bunch of punctuation symbols. But in a lot of languages with accented characters, a lot of Asian characters, this is not nearly enough memory or bits with which to represent all of those possible values. So we need to do a little better than ASCII, but we can build on top of what they did years ago. So here is a chart of ASCII codes. It's just a bunch of columns showing us the mapping between letters and numbers. So for instance,
Letters and numbers.
here is the capital letter A.
I wonder what these other ones are, these lower ones.
'65, capital B, 66, capital C, 67, ... 72 is H, 73 is I.
Oh, like keys? Like escape key? Or something?
67, ... 72 is H, 73 is I, and so forth. There's some weird things over here, like special symbols that we'll learn about over time, but there's a mapping between every English letter of the alphabet and some number, just as you proposed, both for uppercase and lowercase. So for instance, if we highlight just a few of these for now, and I say that I've just received a text message or an email that underneath the hood, so to speak, if I have the ability to look at what switches are on and off, I received this message here. Well, first, and this is not what CS is about, but just fun fact, does anyone know what number this would represent in decimal if this is the binary pattern? Like 1's place, 2's place. 72 is correct. And again, not intellectually all that interesting, and this is not the kind of math that we spend all day as CS, a computer scientist, doing, but it's just following the same darn pattern, which is to say it might look cryptic, but conceptually, intellectually, it ultimately is exactly as we did before. So yes, I'll spoil the rest of the math. It's 72, 73, 33. Now, anyone remember in your mind's eye what message we just spelled? Yeah, so it is in fact high, though no one really said that excitedly. What's the 33, if you noticed? Okay, so a lot of people notice, yes, it's an exclamation point, and that's indeed noticeable right here. 33 is the exclamation point, and that's just something eventually that might sink in. But for the most part, if you remember capital A is 65, you can figure out like at least 25 other answers to these kinds of questions, because they're all contiguous like that. So there's the exclamation point, but at the end of the day, we might just have this mapping known as ASCII, and it's how our phones and computers and devices more generally actually store information. So we thought we'd maybe take a little pressure off of me here, and could we maybe flip things around? How about we try applying this newfound knowledge, if it's indeed new to you, with like 7 volunteers, 7 bits, if we could. Okay, so your hand first, come on down. Maybe your hand's there. Okay, 3, come on down over here. How about 4 and 5? Yep, come on down. Yep, and the black shirt, yep. How about, let me go farther back. How about in the green over there? And how about you, 7 over here? All right, come on down. Come on down. Sure, a round of applause for our brave volunteers.
What, is he going to use these people to represent binary? Okay, back to this. Okay, let me see if I can get to, I don't know, question number like 18 would be good without getting one wrong. Okay. I look forward to higher level math where I can use a calculator. I hate doing hand. 27. 17. Okay, 27. 17. That's so messy. 14. 9. Okay. 19. 7. We're gonna check this. Okay. 8,000 divided by 1,000. Divided by 100. Like, it's 100 times 80. It's 8,000. Okay. Okay, pints and cups. 1 pint is 2 cups. Okay, so 46. Oh, wow. Whoever just followed, thank you. I think what I'm doing is like really boring, but but thank you. 46. I'm just gonna stop. I'm gonna stop when I get to question 18 and going back to CS50. 5. Estimate. Okay. It's like 600 times 200. 12. I think this should be this one. I double check. 600 times 200. And 20,000. 720 seconds to take a shower. Nobody counts the amount of time they're in a shower in seconds. It's 420 seconds to eat breakfast. Shower and eat breakfast. Okay. Minutes. I guess I'll just add them all. Where's my tablet? Together. I don't know if this is the most efficient way to do this, but whatever. Oh, just 40. Okay. 2. It's probably not. Well, this should be 1. Just gonna get rid of that. I hate doing math in my head. Oh wait, no. Check the 4. 11. 54. I wonder if this goes in cleanly. 60 times 9. Oh yeah, 9. Okay, I think that's 19 minutes. I kind of want to double check it though. 19 times 60. 1,140. Oh. Okay. Long division. G6, 80. Okay. was in what, 5, 6, 80. Oh, sometimes 8. 56. So 7, 8. Oh wow. So 71. Oh fuck, 71. That's 80. Oh god. That's 80. Alright, I'm going back to scratch now. 19, 20, 21. Actually, I only have 4 questions left in this unit test, so I better not get a single one wrong.
All right. So if you'd like to stand roughly side by side here in the middle of the stage. First of all, thank you. Let's see, 1, 2, 3, 4, 5, 6, 7. Perfect, okay. And let's go all the way over to this place here. If you would like to introduce yourself.
I'm Rachel Ritchie.
Okay, and what year, anything about you?
First year, concentrating in CS.
Okay, welcome to the stage. Next.
Hi, I'm Kang, also first year, concentrating in CS.
Hello, my name is Lam, a RA student from Education Department.
Nice, okay, next.
Hi, I'm Jordan Mittler, concentrating in economics and maybe some CS.
So hi, I'm Natalia, first year and I want to do CS.
Hi, I'm Khadija. I'm a first year and I want to do CS.
Hello, I'm Caleb, and once again, first year.
He literally said that 2/3 of the students were not concentrating in CS, but this is not 2/3. Like everyone is of the sample he just picked is concentrating in CS.
Concentrating in CS.
Okay, wonderful. A pattern, yes, thank you. Thank you. So, if you haven't guessed already, each of these volunteers is going to represent a bit from left to right, or right to left in this case. So let's see, if you want to represent, how about the 2's place? How about the 4's place? The 8's place? 16th place? 32's? 64? And 128, although, wait, I think I screwed up. We needed 1/8 volunteer. I think you know, well, I think, Spot? Okay. Come on over. If you guys could step forward a little bit and then scooch this way, just to give Spot some room. So Spot will represent the 1's place. Now, what our volunteers have on the back of their sheets of paper are little instructions. We're going to spell out a 3-letter word in English by using 3 bites from left to right, because now we have 8 volunteers. I'm going to propose that you raise your hand if you're supposed to represent a 1, or you just stand there without raising your hand if you're meant to represent a 0. And what we'll have the audience do is do the quick math to figure out 1, 2, 3, each letter, what number is it, what letter is it, and we'll see what word that we finally spelled. All right, so in round 1, you have instructions on your back of your sheet that will tell you to what your number is. If you're 0, stand there. If you're a 1, raise your hand. What number do these guys seem to be representing? 66, I think. 64 plus 2, so 66, which is the letter? Okay, so B. Okay, so B. All right, hands down. Second letter is going to be spelled how? All right. What are we spelling now? I think. Yeah, okay. Yeah, I think you want. Okay. Now what number are we spelling? 79, I heard, which is the letter? O, okay. So hands down. Thank you, Spot. One final flourish. So we've spelled B-O, third letter. Go ahead. What number now is this? I heard it here. 87, which is W, which of course spells bow. So if our volunteers could take a bow spot included. So this will make more sense in week 1 when we have an assignment involving a certain someone from the Nintendo world, but we have a lovely parting gift for each of you. Thank you for volunteering.
Is that a sponsorship?
You might need to share with the folks next to you.
Okay. 4 hours. Trying to get easy questions, please. Wait, hours, okay. Right, 60 minutes in an hour. 240 minutes, 60 seconds in a 6, 12, 13, 14. Oh, it's the same. Let me double check. Seconds. 13,400. Okay. What's 80? Okay. God, I'm actually about to finish the unit test. 123. Oh, wait. Shit, I don't think I have to write it out like that, but whatever. I'll try 6. 13. 9. So 9. Oh, wait. Wait. Oh yeah. 6. 9 range 6. 13. Okay, and the last one's this one, of course. The one with many steps. So, 0, 0, 7, 14. C 140 6 6 3,066. Yeah. And just to be safe, 2,800. Okay, good. And this one has a lot of questions in it too. Yikes.
Here we go. There we go. Thank you so much. One more round of applause if we could for our volunteers. Thank you. Okay. All right. So, Spot's had it. So, let's see then if we've solved now the problem of representing English letters of the alphabet, being able to spell out words like bow, B-O-W, what if we actually do have accented characters? What if we do have other words like bow, B-O-W? What if we actually do have accented characters? What if we do have other glyphs that we want to represent? Well, here, of course, is a standard US English keyboard, which a lot of you might have, but there's also characters that you can type much more easily if you have a foreign keyboard relative to the US, or with certain keystrokes on your own Mac, PC, and phone. But nowadays, too, there's this menu that probably you've used in the past like hour or two to actually say there's relative to the. But there's also characters that you can type much more easily if you have a foreign keyboard relative to the US, or with certain keystrokes on your own Mac, PC, and phone. But nowadays, too, there's this menu that probably you've used in the past like hour or two to actually send some emoji. And emoji, even though they look like pictures, and they actually are pictures on the screen, they're technically just characters. Characters of an emoji alphabet that happen to use a certain pattern of zeros and ones to represent each of these faces, each of these people and places and things. And it turns out that one of the reasons that we have just so many such characters nowadays is because we now use Unicode instead of ASCII. So Unicode is a superset, so to speak, of ASCII, which is to say that we humans realized some time ago that just using 8 bits to represent letters of the alphabet certainly isn't very good when we want to represent other non-English languages. So Unicode doesn't just use 8 bits, it sometimes uses 16 bits per character, sometimes 24 bits per character, and sometimes even 32 bits per character. Now, why those numbers? That's just 1 byte, 2 bytes, 3 bytes, or 4 bytes. And that gives us, does anyone know? That gives us the ability to represent as many as like 4 billion possible characters, because if the longest one is 32 bits, that's 2 to the 32, which if you do out the math, trust me, is roughly 4 billion. So that's a lot of characters, and we've got a lot of room then for these emoji. But it's not just about having sort of fun pictorially on the screen. Unicode's mission really is to represent and to preserve all human languages digitally, both past, present, and future. So it is really about capturing the entirety of sort of human knowledge as we've expressed it in language, but also giving this newfound ability that's been used, centuries ago too, in writings on walls and the like, pictograms via which we can still communicate even independently of our own human language. So we'll reduce it today to just patterns of zeros and ones, but the problem being solved is much greater and well beyond CS itself there. So here's a pattern of zeros and ones using Unicode, so more than 8 bits, that represents a very popular emoji, which might be a bit of a hint. This is the most popular emoji as of last year, at least statistically, internationally. Does this help? It's roughly this number here. No, it's this one here. So this is the most popular emoji by most measures as of last year, but it doesn't always look like this. Those of you who have a Mac or an iPhone recognize this symbol perhaps immediately. Those of you with Android devices or other platforms might notice that it's the same idea, but it's a little bit different. And this is because, too, emojis at the end of the day just represent characters, but those characters can be drawn, can be painted in different ways. And reasonable people will interpret differently this emoji, whose official name is Face with Tears of Joy. And indeed, Google interprets it a little differently from Apple versus Microsoft versus Meta versus other companies as well. So you can almost think of those different companies as having different fonts for emoji. And that really starts to connect things to the world of text and characters. So just so you've seen it, more on this another time, it turns out that emoji and really characters in general, we don't use binary zeros and ones to represent them because no one, myself included, is going to recognize what's what. It's just too much math. It's not interesting. And even decimal numbers, that was like 4 billion or something. Like, I don't remember which number is which. So we represent things a little more compactly. And this, too, admittedly still looks cryptic, but this is a Unicode code point. It uses another system mathematically called base 16 or hexadecimal. More on that another time. System to admit remember which number is which, and even to represent them because no one, myself included, is going to recognize what's what. It's just too much math. It's not interesting. And even decimal numbers, that was like 4 billion or something. Like, I don't remember which number is which. So we represent things a little more compactly. And this, too, admittedly still looks cryptic, but this is a Unicode code point. It uses another system mathematically called base 16 or hexadecimal. More on that another time, but it's just a way of representing numbers even more succinctly, writing less on the screen, because you're using not just 0 through 9 as in decimal, but you're using A through F as well. So a few letters of the English alphabet come into play. But for now, that's just a little easier to remember for people who care, that is the number that represents face with tears of joy. But what if we want to customize emoji? And this increasingly is the case. Here, for instance, are the 5 skin tones that phones and laptops and desktops nowadays support. It's based on something called the Fitzpatrick scale, which essentially categorizes human skin tone into 6, or in this case, 5 different categories from lighter to darker. But this sort of suggests that, wow, if we want to represent people with 5 different skin tones like this, that could kind of significantly increase how many unique patterns of zeros and ones we need for every possible face. But if we think about it from an engineering perspective, we can actually just think of skin tone as modifying some default color, for better or for worse. And like yellow was sort of the de facto default, sort of Simpson style. But to modify it to look more genuinely human-like from lighter to darker, well, maybe we just use the same pattern of bits to represent a human thumb, for instance, thumbs up or thumbs down, and we just then modify that character to be displayed with a different skin tone. So for instance, here then is the thumbs up that you might use on various platforms, and let me just stipulate that this is the Unicode code point. That is the number that Macs, PCs, and phones use underneath the hood to represent the default yellow thumbs up. But if you want to give it like a medium skin tone, you still use that same number, that same pattern of zeros and ones or switches underneath the hood, but you use a few more switches that the computer or phone will interpret as, oh, you don't want to see the default in yellow because of this second number that's in the computer's memory somewhere. You want me to adjust it to be the medium skin tone or any of the other values instead. So that's sort of the engineering solution to this problem of just trying to represent different ranges of emoji here. Well, what about something like this? There's a lot more combinatorics nowadays on your keyboard for relationships, for instance. So here is a couple with heart here. So the couple here, of course, is represented with apparently this number here, but that's it. But if you want to be more specific, like man and woman, or man-man, woman-woman, it's the same idea, but we just need to express ourselves with a little more information. So for instance, the way the Unicode folks came up with years ago to represent, for instance, a woman with a heart and a man from left to right would be using these values. So things just escalated quickly, but only in the sense that we're using more bits, more zeros and ones to represent more expressively this particular combination. So this happens to be the number in Unicode that represents the woman at left. This is the number that represents the man at right. And this is the pair of numbers that represents the heart in the middle, sometimes red, sometimes pink, displayed here as pink. But if we want to change the combination, for instance, to be, say, woman, if we want to change the combination to be woman-woman, notice that now the left and the rightmost numbers match. Or if we flip it back to man-man, it's just using different numbers on the tail ends again. And meanwhile, if I rewind, there's these two identical values here. These are called zero-width joiners, or Zwidge characters. It just is a special number that humans reserve to say glue the emoji at the left to the emoji on the right, and so forth. So it kind of connects ideas in this way. So there's actually a lot of emojis nowadays that are a combination of different things. Like heart on fire is one that's technically the combination of a heart emoji, the fire emoji, joined together numerically in this way. So computer scientists who come up with these things are just sort of reducing things to representations. All we have at our disposal are zeros and ones, so we all just need to agree ultimately, whether we're Google, Microsoft, or the like, how we're going to standardize these kinds of things as information. Questions then on how we're going to ones, so we kind of reduce numerically in this way. So computer scientists who come up with these things are just sort of reducing things to representations. All we have at our disposal are zeros and ones, so we all just need to agree ultimately, whether we're Google, Microsoft, or the like, how we're going to standardize these kinds of things as information. Questions then on how characters are represented in a computer, be it English or any other language. Yeah? How is the what? Oh, the U plus is just a convention, really. So U plus represents a special Unicode character, which is a U with a plus in the middle. And this is just the convention for saying, hey everyone, here comes a number that represents a Unicode code point. The U and the one have the U and the plus have no mathematical significance. It's just a visual clue to folks. Other questions on representing text in this way. All right, so what about colors? We've already started looking at pictures. Well, how are those pictures being?
It's decimal. Okay, well, if it was 2 or 100, 0.02, so 0.04. Four is a decimal. I wonder if I'm actually supposed to divide. Maybe there's a faster way to do it. Oh wait, that's more fascinating. No. 20. Five. Oops. Do this. By factoring out 10. Oh. Wait, so what does that look like? Divided by 60. There's 1.86 divided by 6. Wait, was it 1.86 divided by 6? 31? Okay. Let's take the 10 out. 3 points. 9, 18, 27. 3 goes into 42. How many times? Wait. 1, 12, 14. Nine divided by 30. Oh. Point. 3. Okay. Point. 4, 2. Okay, I can see how that could be useful. There's 20 questions. Start one. Okay. Oh my god. Compare to 15, less than. What? Oh wait, no. I thought that. Okay. It's greater than 1. Does this person get? Ah. That's 6. Let's start at 8 pieces. 1/4 of a whole. How many pieces are there? That's 16. 4 divided by. That's a cool visual. The table below gives the heights of the saplings. 1/4 of an inch. And then I'm gonna below. Okay. 2. 3. 5. 4. 1. 2. Greater than 250. Here, each person in the Taylor family eats 3/4 of a box of cereal. 5 people in the family. 15/4. 16. 12. 4. Fraction multiplication. My lemon line. 3/4. 3. Is that 3/4 times 3/5? Or is 1, 2, 3, 4, 6, 7. I wonder. The shaded length. Three-fourths times. That's fine. Times 4/5. Okay, so I think I can do it like now. I'll just turn the whole thing into a fraction. 12/4. I'm simplify it too. 1 of 3. 12/5. 2 and 2/5. Wait, no. 2, 10. One, 3. 2/5 is not 2/5. 5, 6, 7, 8, 10. Oh wait, that's 11/4. Oops. Okay, 11/4, 4/5. That's 20. 44. Well, let's simplify it. 10. 22. 5, 11. Okay, 2 and 1/5. Okay, 3, 4, 8, 10. Difference between 328. Length of 4 Babby's favorite songs recorded below. What's the total length of all Babby's favorite songs? Of course, I have to add them all up. Well, I mean, this one, 5, 10, this is 11. And then we have 4, 8, 9, 20. Okay, back to CS50.
Emojis or anything else represented, one of the most common ways is just with RGB, red, green, and blue. Emojis or anything else represented, one of the most common ways is just with RGB, red, green, and blue. It turns out that if we just keep track of how much red should be on the screen and how much green and how much blue combined together, that gives us every color of the rainbow, from white to black and everything in between. So how do we represent an amount of red and green and blue? Well, frankly, just with 3 different numbers. And this is how computers typically represent colors. Every one of the dots on your computer screen or your phone screen is called a pixel, and every single dot underneath the hood has 3 numbers associated with it. So 3 numbers, 3 numbers, 3 numbers for every little dot. And those 3 numbers together say how much red, green, and blue should the device display at that location. So for instance, if you had a dot on your screen that said use this much red, this much green, this much blue, because each of these numbers, I'll tell you, are 1 byte, or 8 bits, which means the total possible values is 0 to 255. Let me just ballpark that the 72 feels like a medium amount of red because it's in between 0 and 255. 73 is a medium amount of green, and 33 of blue is just a little bit. So if you combine a medium amount of red, green, and a little bit of blue, anyone want to guess what color of the rainbow this is? Sorry? Brown? So close. It's a little more yellow than it is brown, but if we combine them, it looks a little something like this. This is just CS trivia, not something that even I would be able to eyeball unless I came up with that particular example. But wait a minute. We've seen these numbers before. 72, 73, 33 represented what a few minutes ago. So it meant high, but here I am claiming, no, that means yellow. How do you reconcile this? Well, at the end of the day, this is all we have, zeros and ones, whether you think of them as numbers or letters or even colors now. But it depends on the context. So like if you've received a text message or an email, odds are the pattern of zeros and ones that the computer is showing you are going to be interpreted as text, because that's the whole point of a text message or an email. If, though, you opened up Mac OS's or iOS's or Windows or Android's calculator app, the same pattern of zeros and ones might be interpreted as numbers for some addition or subtraction or whatever. If you open the same pattern of zeros and ones in Photoshop, like a graphics program, they're going to be interpreted in that context as colors. So context matters. And indeed, as soon as next week when you start writing code in that language called C, the onus will be on you, the programmer, to tell the computer, interpret the following sequence of bits as a number or a letter or something else. And you won't have to even worry about what the zeros and ones are, but you need to give the computer a hint as to what type of file or piece of data you're representing. So that gives us bits, and you can actually see these dots, these pixels on the screen. Let me zoom in, and here we have it, just with this emoji, which at the end of the day is a picture that someone at Apple, in this case, drew. And you can see if you really zoom in or take your phone or TV and really put it close to your face, you'll see all of these dots, depending on the hardware. And each of these dots, these squares, is storing 24 bits or 3 bytes. 24 bits, 24 bits, 24 bits. And that's why, ... if you've got a photograph, for instance, that's like 3 megabytes, which is 24 bits, 24 bits. And that's why, ... if you've got a photograph, for instance, that's like 3 megabytes, which is 3 million bytes, well, odds are there's 1 million pixels therein, because you're using 3 bytes per pixel to represent each of those colors. That's a bit of an oversimplification, but that's why images and photos are getting bigger and bigger nowadays. That's because you're using, well, odds are there's megabytes, which is...
Oh. Megabytes, a million bytes. No, that mega, million.
$3 million bytes. Well, odds are there's 1 million pixels therein, because you're using 3 bytes.
3 bytes per pixel. Wait, weren't there... Oh.
There's 1 million pixels therein, because you're using 3 bytes per pixel.
I thought we were using 24 bytes per pixel.
To represent each of those colors.
Is that what we said earlier?
For instance, 24 bits, and that's why...
Oh, we said bits. Oh, 24 bits, which is 3 bytes.
Or
Oh,
bits,
okay.
or 3 bytes, 24 bits, 24 bits, 24 bits. Like 3 are, there's 1 million pixels therein.
3 million bytes. Oh yeah,
because you're using 3 bytes per pixel to...
3 bytes per pixel, which is 24 bits.
Represent each of those colors. That's a bit of an oversimplification, but that's why images and photos are getting bigger and bigger nowadays, because we're throwing even more pixels into the file.
Oh.
Music. How could you represent music digitally using just zeros and ones or numbers? Really. Any instinct, whether a musician or not? Yeah. Yeah, so we could just represent notes by a number. So A is some number, and B, and maybe sharp or flat is some other number. But note might not be quite enough for some, yeah?
Okay, so one note, just rickrolled us.
He rickrolled us. Oh my god, I wasn't sure if anyone would be around to even hear that. I kind of like, I didn't react fast enough. I kind of tried to pause it because I was hoping it wouldn't play the whole song, because I'm like, I'm gonna get copyrighted. Don't play it. Don't do it. I love how you shut up during that part. It's great. It's great. It must be fate, right, Aya? My god. You're like, did he just this professor at Harvard just rickrolled us. Classily. Like, damn. I wasn't expecting that, actually.
Ayaweza says, what are we watching?
We are watching Harvard's CS50 lecture, which is it's their introduction to computer science. This is the first lecture. He's just talking about how different things are stored in the computer, like how the computer stores it, like text and characters and colors. You know, too long didn't read version is everything is 0 and 1s, and yet, you know, and then the binary system, and that's really the TLDR of it. But he's going over a little bit more of the specifics.
Ayaweza says everything is just numbers.
I know, right? How does it? I know you did. How does it feel to be math?
Ayaweza says I summarized you 2 hours.
Wait, that makes me really sad, because it's like, if the universe is just numbers, if we're all just numbers, and I'm bad at math, it's like I'm bad at what I am. You know, I feel like
Ayaweza says yeah.
I know. I feel like an abomination. I know. It's just like can't. It's not fair. It's not right. Okay, I'm gonna take a break.
Says that's why I like it.
That's why it makes me want to cry. Oh yeah. By the way, I found out some sad things. So even though I finished last time I streamed, I finished all I 100%ed all of 6th grade math. But I did miss some things. Well, I didn't really miss anything. It's just that Khan Academy updated a few of their older courses, like the ones before 6th grade, and they added a few more lessons. So now I have to go back and finish the lessons that I missed because they added new content. It's not my fault. I want 100% everything, so now I'm doing just brief, you know. Just I have to go just a little bit back. Just a little bit. It's not a big deal. I'm not mad. I'm not mad. I'm just very mad. It's the fan.
Ayaweza says also there is a weird noise.
I think. It's just because yeah, it was just the fan. I set the computer down in a way where the fan was like blowing into the mic.
Ayaweza says, are you fidgeting around with your mic?
No, it's hot. It's the summer. I need the fan on. I'm not gonna turn that off. You can't make me. I don't care. That lowers the audio quality. It's hot.
Ayaweza says.
Well, air conditioning where I am is not really good, so I kind of have to rely on the fan. But yeah, just gotta deal with it. Which expression is equal to 9/8? 9 divided by 8. Oh wait, simple. Wait, I wish I didn't say that.
Ayaweza says what?
What? What do you mean what? What? You want to talk? 8.8 divided by 4 using place value. Monte made a... How's Zelda going, by the way? Monte made a mistake. Here's Monte's work.
Ayaweza says yeah.
Yeah. Good. Talking is good. Really?
Ayaweza says I could teach you math LUL.
No cap? 8.8 over 4. Here is Monte's work. 88 tenths. Isn't that 88 tenths?
Ayaweza says
oh yeah, it is. It is 88 tenths. Divided by 4. Okay. I guess he can do that. Wait a second. 8.8. Is that 88 tenths? 8 tenths. 88 tenths. Okay, I guess that makes sense. 22 tenths. Wait. You mean Betsy? Wait, what? Doesn't that mean, like, not really? 22... 8.8 is 8800, it's not 88 tenths. 8...
Ayaweza says.
Well, this part, the step 1 does seem wrong, but is this what you call it? 8? Well, point 8 is 8/10. Yeah. Wait, no. Wait, no. Wait, what? Oh my god. Demo. Oh, okay. That's like, I don't really mind. Like, it's fine, I think. But that's agreement, right? That's that's Sanse, I think. Yes. Really?
Ayaweza says yes.
Well, you might then unfriend me because, like, I'm so thick-headed. I'm so dumb. You're gonna be like, wow, I really regret offering this. That's what you'll think later on. 80, 22 tenths, 88. Wait, if this is 22 tenths, 2 tenths, 22 tenths. Wait, so this is not 88 tenths. But that's not 88 hundredths. 88 tenths divided by 4 is... What?
Ayaweza says I used to teach children how to play guitar.
Aw, that's so cute. You did? I'm like imagining you teaching kids to play guitar. Ah, that's cute. Aw. I think it'd be really funny if a kid just, like, you know, grabbed the guitar and started, like, smashing it or whatever, and just like, stop. I don't know. Kids. 88 tenths divided by 4. But what is wrong here? It's not... I don't think this is 88 hundredths. But I don't think it's 88 tenths either.
Ayaweza says like 80% of them didn't want to actually www.
Maybe this is called 22 tenths. Oh, well, okay. That makes sense. They are just kids. Honestly, when I was a kid, oh, he would have hated me as a kid. When I was a kid, I didn't want to do anything. Especially anything that adults told me to do. I just didn't want to, like, yeah. It's a good thing I grew up in that sense. 22.
Ayaweza says I want to do a lot of things.
Ooh, like what things? Oh wait, I feel you. I feel you. Literally.
Ayaweza says wanted.
Oh, when you were, okay. Aww. Well, it's okay. At least now that you're an adult, you know, hopefully you can make all your dreams come true. Well, that's what I hope for everyone. Every adult. No offense to the kids. Who are still kids, but I'm biased. Okay, I'm adult, so I'm biased. Actually, I didn't know 2.2 was read. So it is C, but I didn't know it was read as 22 tenths. I actually thought 22 tenths was 0.22. Because, like, 2 and 22. Anyway. I didn't know about this type of notation. Well, it's not really notation, but...
Ayaweza says NA kids don't deserve anything www.
Yes! Okay, cool. We're on the same page. Good. No kids allowed. Oh wait, that reminds me. There was like a really funny video in that theme. I wonder if I can find the link. It was really funny. Oh yeah, I remember. I think I can find it really quick. This is great. This is how I feel about children. I'll send the link. Oh, here, it's this. Let's get my Twitch chat. Okay, give me a second. Just need to open. There we go. Yeah, so this is how I feel.
Salttoserenity says https://udo.be/d0tt6wp/si=sign GQ JOMWZ6T del quid.
Okay, 2080 is a decimal. Oh, wait, 80, 28. Okay.
Ayaweza says 10/10 www.
10. Oh yeah, I know. I love this. Oh no, yeah. Oh no. What will I ever do without my child? 1624. It's great. But yeah, I like the video. It sums up exactly how I feel.
Ayaweza says 7/20.
7/20. I have to write as a decimal. As a decimal. 80. I don't know, times 5? Oh, 5. 3.5. But I'm also going to double check it with a calculator because I don't like starting from question number 1. It's just not fair. It's just not right.
Ayaweza says 7/20 is easier to compute than 28/80 www.
Oh wait, actually I had the decimal wrong too, but it's fine. Oh, I see what you mean. I see. You simplified it. Lol, and then I went and immediately went for the division. Yeah. Wait, how'd you oh yeah. Wait. Oh. Okay. Wait, 7/20ths? Wouldn't it be 14 over 20? Oh wait, no, I'm stupid. Never mind. Because it's 40, because you divide, okay. It's 14 over 40, 7/20. Yeah, you're right. Which problem could be solved with the expression 32 divided by 3 plus 1? Greg.
Ayaweza says 8,888.
Yay, 8,888. That is Hasenijo. He says this with the choice evenly between him and his two brothers. That's not that. Betty has 32 students. She tutors. She got 3 additional students. She then advertised and got 1 more student. How many students does she have now? 32 choices. Split the choice evenly between him and his 3 brothers. Okay, it'd be this one. Okay. Which problem shows the same relationship? It's 1 divided by 4 divided by 2.
Ayaweza says I just noticed you've been studying the whole day.
Have I? No, I haven't. Have I? Oh. Am I doing that bad? Damn. I mean, well, the last time you visited me, I didn't keep studying, you know that, right? I did end the stream for like a good 8 or 9 hours where I slept and ate food.
Ayaweza says no, that's fine.
Oh, okay. But yeah. Better do this and work on something than to just, waste all my time watching shorts on YouTube or something, or, just endlessly watching clips on the news and random things and wasting time. I'm looking for same relationship. Okay, so I guess I'm just rearranging this
Ayaweza says yeah, this is way better in general.
Oh. I think it's this one, right? Because 2...
Ayaweza says forcing the nugging work.
I know, right? I'm hoping the more I do this, because you're right, I barely ever force the nugging to work, but I'm hoping if I do it enough, like nugging can grow a tiny bit bigger, you know, maybe like I can get an extra, maybe 1 or 2 extra brain cells per month. I would be very satisfied if nugging can achieve that. Oh my god, I love that you call it nugging. That's so cute. Nugging. Oh my god, I'm gonna start using that. It's so cute. But yeah. Exactly. Right, because if it was 1 divided by a 4th, then it would be 1/4.
Ayaweza says people don't say that anymore, don't they?
1/8. 2 divided. I'm gonna double check. 2 divided by 0.25. People. What? I just have never heard it, but it's so cute. I love it. 2 divided by 0.25. Oh my god! Wait, that's not. That's wrong. It doesn't even equal that. 1/4. What should be? Wait. Oh yeah. 2 times 1/8 is 1/4. Wow, that was a close call. Tasha spent 1.5 hours on the beach. She fell asleep for 3/4 of the time. Jealous, she was on the beach and then woke up with a terrible sunburn. How many hours did Tasha sleep on the beach? Okay, 3/4 of the time. So it's... Oh, they want hours, okay. 1.5 hours, 3/4 of that. Well, 3/4 of... I think it is. Maybe I can do this in my head. 3/4 of 1 hour is 45 minutes. Wait, is that how you do it? 50, 30, 45, 60, right? 50, 60, yeah. So 45 minutes for the first hour, or for the 1 hour, and then 3/4 of 1/2. So that's 30 minutes. Wait, actually, how do you do that? Okay, never mind. Maybe I should just convert everything into... Maybe I should just do 1.5 times 0.75 and just cop out. I don't know. Maybe there is a way to just solve that really quickly. But, you know, I'm bad at math, so... Oh my god, hold on. My wires are all tangled up. Oops. But wait, I probably could just... 3/4. 3/4. Wait, 2? I could just do this. 8, 9, right? And then it's like 1 and 1/8 hours. Wait, was I supposed to add those? Oh wait. How many hours did she sleep? Wait, what did I just do? I think I just multiplied. But that's what I'm supposed to do, right? Multiply them.
Ayaweza says there is a thing called the rule of 3.
One and 1/8. Wait, I will double check this. I'm not gonna just put it in so I don't mess this up. The rule of 3. Never heard of that. 1.5. Okay, 1.5. Checking with a calculator. Okay, 1.125. So 9/8 is 1.125. 1 and 1/8.
Ayaweza says just Google it like that. The rule of 3 math.
Really? Is this gonna make me more confused?
Ayaweza says I don't know www.
Oh no. Lord have mercy. What the? Verbalize the process of solving basic linear equations. 4 terms. Where 3 of the terms are known. What? There's not 4 terms where 3 of the terms are known. I think. It was just 3/4 times that number. I think. 1/8. God. D equals PCA.
Ayaweza says I don't
Times B
remember the
times
problem
B.
already LUL.
Mole D right C D.
Ayaweza says but usually this one helps you to solve that kind of problems.
Just do AD equals BC and then divide. Oh yeah, and you just divide BC by A.
Ayaweza says like if $1 equals 20 pesos,
The
how many
pesos.
pesos are $25?
Oh yeah, like converting. Like proportion, keeping things in proportion, yeah. Yeah, I think I've used that before. But that one was just asking for,
Ayaweza says yeah.
yeah. Well, I guess I see what you mean. So 3/4. But that was more like, I think it was just, there was no missing value to keep something in proportion.
Ayaweza says maybe I
Right.
didn't read it properly.
I never read
LUL.
anything properly, honestly. 1/8. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 2. Let's see what this one, because this is 6. How does this image even show that? 1/8. 1 by 2. Oh, I see. Because it's 1/16. Sally did measuring a flower for a science project. The flower has grown half of a centimeter each day and grown a total of 2 centimeters taller. How many days has Sally been measuring this flower? 4 days?
Ayaweza says.
This better not be a trick. That seems too easy. 1/2 centimeter. 4 days. Okay, I was gonna cry if it was wrong. Okay, I have 2 questions. I cannot get them wrong. I cannot. It's following units to multiply. 1/3 times 6. 1. Why are they numbered like 1, 2, 3, 4? Wait, no. Times 6. Two. It's like 1, 2. Oh my god. Okay. And if they want, take the 0 off, move the 0 here. 0.9 times, what was it? 6 is 54? I think. Let me double check. 4. Got my 90. Okay, I almost got it wrong. It's supposed to be 0.06, but if you move this, and then, oh yeah. Wait a second. 9? Oh yeah, 9 goes into 54. Oh yeah, I see why. I just don't line things up. Sigh. At least this one's only 11, not like freaking 20. But dang, I don't even think, I don't know, maybe I'll try to finish Unit 5 and finish this 5th grade for Eureka so I can keep my 100% on everything. Maybe. It's kind of a lot. 11, 12, 1, 2. Yeah. I'm starting to feel it. You're right, I haven't streamed for a little bit of time. I am starting to feel it. I'm feeling it. The burn. Ah. Okay, I think you said you gotta go for a bit or something. Wait, that's what that means, right? I think. That's like, what? How do you say it? Ritsuseki or something? Let's see, what would Jisho say? Wait, no, I want Jisho. Oh, Miseki. Right.
Note itself, the sound or the pitch, one other number to represent the duration, like in the context of piano, like how long is the human holding the key down, and maybe I can think of a third, like the loudness, like how hard has the person played that note. So minimally, with 3 numbers, you could imagine representing music as well, and indeed that's very well might be what computers are doing when you listen to sound. What about video? How could you represent videos as well? Yeah, many images. So if you've ever like produced a film or looked at some of the fine.
Wait, what is this whole section about? Volume. Okay, I do really want to finish the 5th grade thing. Of course, it's 7 questions. But this shouldn't be bad. 9. And 7. 6. 6. 4. Okay, I do not mean to do that. 2, 12, 18, 24, 32. What? 6, 12, 18, 24, 30. Oops. I would say 32. Oh. It's okay. Well, 1, 2, 3, 4, 5, 6, 7, 7, 14, 21. 3, 4, 5, 6, 7. 9. Okay, there's only 11. Assessing a cube, switch to prisms, curve volume. Oh, wait. 12 times 3, 6, 36. 1, 2, 3, 6. This one. Triangle is true at both shapes. Okay. Equal length. Equal measure. Okay, 15 times 9. And 35. Wait a second. Oh wait, 15 times, oh wait, no, I did see that. Is it supposed to be 270 divided by 135? Oh god. It doesn't fit in nicely. Wait, unless 135 times 2. 6, 7, 2. Oh, so it's 2. Thought it wasn't giving some crazy decimal. Five. 8. 2, 3, 4. One, 2, 3, 4. Oh wow, that's quadrilateral too. Square. Oh no. And parallelogram. What's rectangle too? What's a rhombus too? Right? What is a rhombus? I forgot. Oh yeah. It's like, it could be a square, but like, tilty square. 2 rectangular prisms. What is the volume of this figure? Okay. 60, 120, 180. And 4, 4. Is 6, so 6, 24 times 4. 8, 9. 6, 6. 17. 2. 276. 3 units. By 1 unit rectangle shown below. What is the area of the shaded rectangle? 3 unit by 1 unit. What's it showing? 3, 1, 1, 3 fifths. Huh? 1 fifth, 1 fifth, 1 fifth. 1, 2, 3, 4, 5. Yeah. 3 fifths. 6 fifths. Well, 9 fifths. What, take that? Unit cube. What is the volume of the following figure? Okay. 1, 2, 3, 4, 5, 10, 15, 16, 17, 18, 19,
always
20.
says.
Oh my god, 2 more and I'm done with the 5th grade, and then I'm done with math for the whole day. And maybe I'll watch some more CS50, just a little bit more. I'm not gonna finish the whole lecture, and then eat some food, then pass out and die. That sounds good. Oh wait. Oh, you're back. What is it? It's oh yeah, Kairi. Oh no, not yet. No, I still have some.
always says.
I still have a few tiny bit of loose ends to wrap up. Because it's not just 6th grade, 5th grade, whatever. There's this other thing called Eureka Math, which basically it's like extra content. So I'm just doing the little extra, because they added new content into this, so I have to do it, okay? But it's okay, I'm almost done with the 5th grade, and that means like I'm done with 5th grade for Eureka, I'm done with normal 5th grade, so now I'll just need to do the 6th grade Eureka. But I have most of it done anyway, so it's just, it's not the end of the world, but it's still annoying. I hope that makes sense. Sorry, that wasn't a good explanation. Ah. But yeah, I'm glad to see you back. Two pairs of opposite sides that are parallel.
Smith says hi.
Opposite of a rhombus or
Smiley
parallel.
face.
Oh, it's a hard question. Is a rhombus also a parallelogram? Wait, 2 opposite sides of a rhombus are parallel? Yes? 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 Oh god, thank god. 1 cubic unit. Okay, I can't get this wrong. What is the volume of the following figure? All the cubes are visible. Literally, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Smith says yes. Smiley face.
Yeah, I can't get. It's literally counting. I cannot get this wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cubic units.
Ayoways says, yeah, it did make
I
sense.
can count. Yay. Yeah, so BC, I finished. Okay, I remember I finished all of 6th grade. Well, there were a few loose ends I never tied up, so I had to go back and just like finish a few loose ends because they added some new content. So, because I need to keep my 100%. Also, I did the
Ayoways says she can count pog bones.
I can count. I'm so proud of myself. I can count cubes. But by the way, so I did 6th grade, but I'm still missing a little bit of the Eureka 6th grade because it's like a different thing. Oh my god, illustrative mathematics. I've never seen this before. Okay, wait. I might be missing more than I thought I did. Because I might be missing this one too. God damn. Okay, it doesn't matter. So I have the 6th grade foundations for Eureka. No, I don't. Okay, so we're gonna do this later. Because I gotta do everything. And then I gotta do... What's the other one? This is the 6th grade. The other Eureka. There's another one too. Actually, this is horrible. Now I'm thinking about it. I didn't click on the same thing twice, right? Because there's 2 Eurekas. There's a foundation Eureka. Or whatever. Yeah. You know what? I hate it here. And then there's this. I just saw this for the first time. 6th grade illustrated mathematics. And I'm missing stuff in here too. Great. So gotta go do those later. But not now. I'm not doing it. I'm done with math for today. I'm just saying that I thought. Well, there's things that have to be cleaned up. Sadly. That's 22, of course. So, okay. It's okay. I'm not mad. I'm not mad. You're mad.
Fine print, 30
We'll go back to this.
frames. Yeah, many images, videos as well. Yeah. Yeah, many images. So if you've ever like produced a film or looked at some of the fine print, 30 frames per second, FPS, or 29
I stream at 30
per
frames per second.
It's just how many pictures are flying across the screen, but that's really all a video file is on a computer. Lots of pictures moving so quickly in front of us that you and I, our brains, interpolate that as being actual motion. And in fact, from yesteryear, motion pictures, it's like pictures that are giving the illusion of motion, even though there's only 30 or so of them flying across the screen. So we have a way now to represent information both as input and output, whether it's numbers, letters, images, anything else. Let's now focus on what's inside of that black box, so to speak, wherein we have algorithms, step-by-step instructions for solving some problem. Now, what do I mean by algorithms or step-by-step instructions? Well, maybe if we were to turn this into code, and that's how we'll connect the dots ultimately today, code is just the implementation in computers of algorithms. An algorithm can be something we do in the physical world. Code is how we implement that exact same idea in the context of a computer instead. And here, for instance, is a very common application inside of a computer for your context. This is like the iOS version of the icon. And typically, if you click on that icon, you'll see something like all of your contacts here, typically alphabetical by first name or last name. And your phone or your computer lets you often search for someone's name at the very top, and it will sort of autocomplete. And it'll be pretty darn fast, but it'll be pretty darn fast because the programmers who implemented that application are looking for someone quickly for you. Now, I can do this sort of old school style, whereby we have one of these things
I know who's
from
gonna get a phone book. I knew
yesteryear,
it.
an actual phone book. So in a physical phone book like this, you might have like 1,000 pages, and on every page are a bunch of names and a bunch of numbers.
Oh my god, do you guys know the trick on how to rip a phone book in half?
And as I flip through this, I could look for someone specific. So suppose I want to call John, and as I flip through this, I could look for someone specific. So suppose I want to call John Harvard, whose first name, of course, starts with a J. Well, I could just turn page by page, looking for John Harvard, and if he's not there, I keep turning and turning. So this is an algorithm. I'm stepping through the phone book one page at a time. Is it correct, this algorithm?
Ayoways says the hell
Assuming
are
I'm
you
looking
talking
down.
about, Jay?
What do you mean, how am I talking about? You can rip a phone book in half easily by... There's a trick. So if you hold the pages in between your hand, like the whole phone book, you kind of like squish it a little bit. Like squish it, like bring it in, you know what I mean? Like squish it in towards your body. And what you do, the point is, you're supposed to create a little layer of air in between each page, and that lets you rip, like, you can rip each page, but you can do it really fast. So basically, you're ripping the phone book in half. But by having that layer of air, you're actually ripping each individual page. You're just ripping it really, really fast. But that lets you rip the phone book in half, because if you just rip it all in one, you know, it's too thick. So that's what you do. You just create a little layer of air between each of the pages when you tear, and then you can actually rip the entire phone book in half. Like, you know, it's a classic magic trick. Just saying. Well, you know, I know, right? I remember I once watched.
Says the more you know, I guess.
I know. I once watched a YouTube series on like just some very classic magic tricks. So I remember that one. It's cool, but that one's more like based on science, to be honest. But it's still really cool. And if you don't know what the trick is, if you don't know how to do it, then it's like, oh my god, you must be so strong. But nope, anyone can do it.
So at a time, is it correct, this algorithm? Assuming I'm looking down. So yeah, I mean, it's kind of stupidly slow, because why am I wasting my time with the A's and the B's and the so forth? I could probably take bigger bites out of it, but it is correct, and that's gonna...
Wait, I'm kind of curious if... Oh wait, no, never mind.
With the A's. So yeah, I mean, it's kind of stupidly slow, because why am I wasting my time?
Okay, I'm gonna stop once I hit an hour in, because this whole lecture is like 2 hours. So once I get, like, you know, 7 more minutes, and then I'm gonna go, I don't know, eat some food, and then die.
And with the A's. So yeah, I mean, it's kind of stupidly slow, because why am I wasting my time with the A's and the B's and the so forth? I could probably take bigger bites out of it, but it is correct. And that's going to be one of the goals of writing code, is to, of course, solve the problem you care about correctly. So correctness sort of goes without saying, else what's the point of writing the code or implementing the algorithm? All right, well, let me at least speed things up. So instead of 1 page at a time, so 2, 4, 6.
Aw, don't be sad. I just drew for a long time. I just need brain need what did you say? Noggin? Nuggin? I forgot what it was. It was really cute. Oh, nugging need break. Oh, poor sad is so sad. Especially when you use it. Actually, you're the only one I know who uses the poro sad. Poro sad. Wait, Aya. Do you play, like, League or something? Maybe we could play a game or something sometime. Just for funsies, you know? Oh, okay. Sad. Poro sad.
Ayaweza says no.
Oh, okay. It was a good guess. Nanamio. What's that?
Ayaweza says.
Oh, anything's good. Oh. Well, I mean, anything you have. What do you have? Maybe I asked you that once before, but that doesn't mean I can't ask again.
Says I just like the emote.
I know, I like the emote too. But it's so sad. Poor Poro. Oh god! Oh, sorry, I just dropped something. We are.
Ayaweza says, aren't we friends on Steam?
I think so. Are we friends on Discord? I hope so.
I don't remember.
In case you're not, you should add me. But, yeah, what do you play, Aya? 'Cause, yeah. Well, I know you play, like, you know, visual novels and things like that. And Zelda and Japanese games. But what multiplayer games do you play?
6, 8. All right, well, let me at least speed. Ignore that. 10, 1 page at a time. So 2, 4, 6, 8. Don't ignore that. 10, 12, 14, 16, and so forth. It's a little hard to do physically, but it sounded faster. It was twice as fast, theoretically. But is it correct? So no, why? Yeah. Yeah, I might miss John Harvard, because just by accident, he might get sandwiched between two pages. But do I have to throw the algorithm out?
Oh, okay. Then, what about Discord? He sent me a... Well, I can just... I don't play games. Seriously?
I don't play games, LUL.
You don't play games? Oh. Not even one? I'm so surprised. Not even one game? One? No, multiplayer games usually are competitive, to be fair.
Waza says, or competitive ones.
Not even like Monster Hunter? Come on, that's super Japanese. Oh my god.
Out all together? Like, probably not. Like, once I reach, like, the K section, which is past the together, which between two pages, but do I have to
play it together?
Okay. If I can, hopefully I can afford it at that time, but still. Yes. As long as I have it. Definitely. Actually, when new stuff comes out, it's best to buy the old stuff, because then that's when the old stuff gets really cheap. But let's do it. We should. And have you even played a Monster Hunter game before? Because if you haven't, that's okay. I can teach you everything, because I've played a lot of them. I'll carry you.
Throw the algorithm out altogether? Like, probably not. Like, once I reach, like, the K section, which is past the J section, I could double back at least one page at least and just make sure I didn't blow past him completely. So that sort of is twice as fast, because I'm going 2 pages at a time plus 1 extra step. So it's still an improvement. So the first algorithm, worst case, if it's not John but someone whose name starts with Z, that might take me a full 1,000 steps. The second algorithm is just like...
Waza says I have, since Monster Hunter 2.
Oh wow, those are all multiplayer games, so you lied. You do play multiplayer games, because they actually count.
Waza says they have become pretty easy though, LUL.
Wow, you gotta do them dirty like that. Easy until you go for the, naked no armor run.
500 steps, because I'm going 2 pages at a time, plus 1 in case I have to double back, but that's in the worst case. But most of us in yesteryear, and what Apple and Google...
Who even says yesteryear?
Google and others are actually doing is in software or here physically, we're typically going roughly to the middle, especially if there's no cheat sheet on the side like A through Z. I'm just going to go to roughly the middle, and here I am, not surprisingly, in the M section. But what do I now know? If this is the M section, where is John Harvard? So clearly to the left alphabetically, and so here is where we can take a much bigger bite out of the problem. We can really divide and conquer this problem by tearing the problem in half, throwing half of it away.
He did the thing, he tore the phone book in half. Sorry, I'm just saying he tore it in half. He did the trick.
By tearing the problem.
See, it looks cool, but he's not really tearing it. He's like, you kind of scrunch it a little bit.
Problem in half, throwing half of it
says he did it the easy way though.
Away, 500 pages away.
I should write. Oh yeah, with the other way, you can actually tear it, not from the binding, but you can actually tear it in half. You're right, from the middle of the, where you go to open the book, sorry. Hamburger, not hot dog. Hamburger. There. That's the best way to describe it.
I
Yeah.
know Waza says W.
Yeah.
Hey, tearing the out of the problem, we can really divide and conquer this problem by tearing the problem in half, throwing
Yeah, that did look lame when he did these away.
half of it away, 500 pages away.
Oh my god, it would have been so funny. He threw it on the stage, but it would have been hilarious if he tossed the other half of the phone book into the crowd and like hit a student with it. It would have been awesome.
Leaving me with a smaller problem, half as big, that I can really just now repeat. So I go roughly here, and now I'm in the E section. So I went a little too far back, but what do I now know? If this is the E pages, where's John? So now he's to the right, so I can, again, hopefully he's not on that page, I can tear the problem in half again, throw that 250 pages away, and now I've gone from 1,000 to 500 to 250 pages. Like, now I'm moving, because the first algorithm was 1 page at a time. Second was 2. This is hundreds of pages at a time. And if I go roughly again to the middle, roughly to the middle, roughly to the middle, hopefully I'll find John Harvard on one final page. Can only do this once, but one final page. So that kind of invites the question, I would think, if the phone book does have 1,000 or so pages, how many times can I divide the problem in half to get down to one last page? So it's roughly 10, and the quick math is like 1,000 goes to 500 to 250 to 125 to like 67 something. So we have to deal with rounding issues eventually, but assuming we work out the math, it's roughly 10 page tears. And that's crazy faster than work out the math, it's roughly 10 page tears. And that's crazy faster than 1,000 pages
says,
and still faster than 500.
Problem in half. Throw that away. You deal with it.
Yeah. So he's like, indeed. I love the way he tosses the pages to the side. Like, he does it in such like a delicate way. Like he's like throwing fairy dust onto someone. It's great.
100 pages. So it's sort of fundamentally better. And indeed, if I finally get to that final page, you know, in the software world, you'd see something like this: John Harvard and his number, which you're welcome to call or text. But that's how we now have our answer, much like the single page there.
Wait.
But how
oh my god, I
you'd
just
see
like
something
blanked out and missed a whole sentence. Don't worry, this is why once I reach an hour, I'm stopping, because I need rest.
Like this: John Harvard and his number. Get to that final page. You know, in the software world, you'd see something like this: John Harvard and his number, which you're welcome to call or text. But that's how we now have our answer, much like the single page there. But let's consider just how efficient that actually is. So here's a very rough, with broad strokes, a chart. So here's an XY plot. So here on the horizontal is going to be the size of the problem. And by that I mean, how many pages are we trying to go?
Wait, this is reminding me, just looking at this chart, of what you said in a second. Tear the problem in half, throw that away, deal with it.
Go through. This would be 0 pages. This would be a lot of pages. How much time does it take to solve the problem? How long does it take to find John Harvard or anyone else? This means like no time. This means a lot of time. So what's the relationship among these algorithms? Well, the first one is actually just a straight line. If there's n pages in the phone book, well, I claim that it's kind of a one-to-one relationship. Because if, like, Verizon or the phone company adds another page next year, that just means I might have one more step next year as well to find John Harvard or anyone else. But the second algorithm, it's also a straight line, but it's lower, even though it might not look obvious. And what do I mean by that? Well, let me just draw some temporary lines. If this is how many pages are in the phone book, ... notice that it takes this much time on the red line to solve the problem. But if I instead use the second algorithm, it takes me half as much time. So even though they're both straight lines, one is strictly lower than the other, which means it's faster, it's better. But the third algorithm is a fundamentally different shape, and it looks a little something like this. And it looks like it's going to flatten out. But
oh my god, math things are showing up now. Wait, let me take a second to look at the lines. Take a good long look at the lines. Okay, so... Size of problem. don't know why. I'm kind of surprised by the way the n divided by 2 looks. I don't know, I thought it would be more like this or... Wait, but then that would be... Wait a second. Time to solve. Size of the problem. But here are the size. Oh. Yeah, it solves it. Okay. Now I see. I just have to think about it. Because if the size of the problem was bigger...
Those are pretty bad graphs, www.
Yeah, if the size of the problem was bigger, it basically... Like, it would take the same amount of time to solve as the first one, because this one is twice as efficient as the first one.
Ayahuasca says they are exaggerated to make it clear.
There. What? Oh, okay, yeah. Oh, it seems super exaggerated. The way it just, like, sticks up instead of, like, okay, well, whatever. But it's okay. It's okay. Oh, yeah, so I feel, Matt, PC, no. The computer science now is turning into math. Oh, and we got logs. Logs! Okay. I just kind of learned about this for the first time-ish, to be honest, like 2 days ago. Logs tell you how many times you multiply a number by itself to get another number or something. In this case,
Lingo says I'm slowly starting to warm up to CS over the past few months.
2. Oh, that's good. You see, that's really good. Nice. Wait, don't you stream PC Lingo? Or am I thinking of someone else? Okay. But if it's log 2, or what, I don't know how to say it, log base 2 or something, then that means...
Peach Teolingo says I used to a while back.
Oh, okay. Got you. I think you said that in the past too. It's like 2, doesn't that mean like how many times? How many times do you multiply 2?
Ayahuasca says log 2 is fine.
Yeah. But like log 2's... Well, I'm just trying to understand the meaning of log 2. Log base 2. Oh, that's what it's called. Log base 2. That means how many times do you multiply 2 by itself?
Says both of them work.
How many times do you multiply 2 by itself to get n? That's the meaning of log 2n? Or... How does it work again? What does the base do in the log? I mean, I know the log has to do with how many times... like an exponent, like how many times a number is being multiplied by itself, but how does the base affect it?
Smith says log underscore 2 8 equals 3 smiley face.
Log 2 8 equals 3.
Ayahuasca says ln underscore 2 y equals x.
Oh god, actually. Oh, what is the value of x? Yeah, 2 to x. Such of? 2 to the x is y.
Peach Teolingo says 2 cubed equals 8.
Into y. In? Oh wait, that's not supposed to be log. Oh, is that the natural log? I hate this. I hate it here. 2, 3. Oh, 2 times 2 times 2. Is 8. That's why log 2 of 8, 3. Aha! So it's how many times 2 multiplied by itself? 8. Okay. You say, hey, go ahead though, but I say, for me at least, you know, you go ahead though. What's the other one? What's the other word that's good to say?
Smith says log underscore 3 81 equals 4.
So 4 Wait. Log 3. 3 times 3 times 3. Wait, 3 times 3 times 3 times 3 is 81, I guess. Let me do the math. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. And 12 times 4 is number. Okay, calc. Okay, you know what? Screw it. I don't want to do it anymore in my head. Calculator. 12, 4. Wait, what? 4 times some 3. Wait, no. 3 times 3. Well, I could just do 3 to the 4th power. What am I doing?
Smith says 3 is the base. 4 is the exponent.
Right? 3 times 3 times 3 times 3 times 3. 81, yes.
Ayaweza says ln minus 1 equals I pi.
Stop saying math things, peoples. Too much math. 3 base 4 exponent. But yeah, that's the important thing. The important thing is I know that like that's the pattern. It's 3 to the 4th power is 81, and that's what log 381 equals 4 means, essentially. Okay, cool. So, back to graph. Thank you, Aya. Thank you. Thank you, guys.
Ayaweza says you have the idea.
Log, and now I know how to say it. It's called log base 2 n. So this would be like instead of the 81, or instead of the, what's the other one? The 8, when you said the log 2, 8 equals 3.
Peach Tealingo says we're kinda seeing how many times do you multiply the base until you get the function input.
Okay. At least for natural numbers. Ooh, it's so cool. But I kind of wonder what this means when there's... Because the ones you were showing me... Well, the ones I've seen are the ones with, you know... You have the equal sign, equals something. But here, it's just log base 2n. But there's no, like, equals something. But I guess it's just saying... I guess it's just saying you keep multiplying it. Like, you keep multiplying 2 by itself. N. Like, for any number, like, I don't know, like, 5, I'm trying to think of this, like 5. Like, if it's 5, it would be 2 to the 5th power. Or something. Maybe, that's what that means. And then it looks like this. Oh, like flats.
Ayaweza says you don't know how to graphs.
I don't know anything, Aya. Why would you ask me that question?
But it never does. It just rises ever so slowly. And what this means is that if maybe Cambridge and Alston here in Massachusetts merge next year.
Ayaweza says www.
Oh, I see. So this is that's why this is so effective, an effective way of solving this. Because basically, when you keep dividing the problem in half and half and half, like, even though the problem gets huge, like, the time to solve it doesn't really increase that much after a certain point. Like, it's barely increasing. That's good enough. That's so cool.
And what this means is that if maybe Cambridge and Alston here in Massachusetts merge.
Smiley face.
Magic! It's magic! Math is magic! Sick RoboBeat. Where's the RoboBeat?
Doris Wright says sick RoboBeat www.
There's a RoboBeat? Mathematics! I never thought of that. Yes. It's magical. I love math. No, I don't. Wait, I take it back. Wait, no, I don't take it back. I just... mixed feelings. Mathematics.
Next year.
Oh, wait, do you mean my TTS? Is that the RoboBeat?
Ayaweza says nerd.
We go from, this means is that if maybe Cambridge and Alston here in Massachusetts merge next year, so we go from a 1,000-page phone book to a 2,000-page phone book, that kind of means, like, if we're here this year, we're over here next year, it's not all that much higher. But it would be much higher if we were using the first two algorithms. Why? It'd be an extra 1,000 steps to find someone in that combined phone book, or maybe another 500 steps. But to be clear, if we're using my third and final algorithm, how many more steps will it take me next year when Cambridge and Alston merge into one 2,000-page phone book? Just one more step, no big deal, it's one more page tear. And this is what we mean ultimately about not just writing code or implementing algorithms that are correct, but now that are well designed or efficient specifically. And this is what makes someone a better programmer perhaps
Wait,
than
this is
someone
why
else.
I'm a bad programmer, because whenever I make an algorithm to solve a problem, it's always one of these end lines. Like, it's
Smith
never...
says basically the question is how many times do you have to have a number? So with twice as much input size you increase the calculation time by only one more.
I didn't think about that. How many times have to have a number? Twice as much input size, you increase calculation time by only one more. You're good, I'm thinking about it. Twice the input size. Well, yeah. That's cool. Which is a lot less than the other ways, because you would have to do it, calculate, you know, many more times than just like one extra. If you like double, and that's cool. I'm definitely gonna have to watch your whole series, VCE, your whole like YouTube series that you have. Especially the ones, I'm definitely going to watch all of them before I end up going into calculus, because I think they'll be super helpful. Hey.
Just one more step, no big deal, it's one more page tear. And this is what we mean ultimately about not just writing code or implementing algorithms that are correct, but now that are well designed or efficient specifically. And this is what makes someone a better programmer perhaps than someone else, or a better problem solver than someone else, is acquiring over time
I'm a bad problem solver. I'm sad.
these skills so that, sure, you could solve the problem sort of quickly and dirtily, so to speak, but if you're going to have a lot of data eventually, be it in your phone book or maybe your Google website index if you're searching the web, you're going to want to try to think about how to design algorithms that look like this. Mathematically, this is called a logarithm.
This is why I need to learn math, because I need to design algorithms that do this. You know?
Peach Teolingo says just gotta make it a habit to think outside HTE box.
Yes, it's so hard to do, but that's why, aw. BCE, you're so nice. You guys are all so nice. Why are you so nice? God, I gotta not give up now. I gotta, no matter what happens, you know? Because you people, the sunk cost fallacy, you guys have helped me a lot, and you've been very nice to me, so it's like, it has to, I gotta make it count. I gotta show you I'm at least trying, right? I'm trying, no matter how much I fail. Oh my god, Automod held, that's hilarious. It held your message, Aya, because it says you were being excessively aggressive to me.
Smith says I'm mean.
You're
smiley face.
You're bullying me. That's what Automod said. It's okay. Tough love is still love.
Ayawaza says www.
And if I ever write code that, like, and I solve a problem, even if I do get the solution, if I write really inefficient code, like, I need people to tell me that so I can, like, try to improve. All these things. I'm so close to the end. Well, not the end, but, you know, the stopping point.
And it's log base 2 because I'm having algorithms that website index.
Ayawaza says, did you check the game I told you?
You told me a game? What game? No, I don't remember this.
Searching the web, you're going to want to try to think about how to design your Google, so to speak, website index. If you're searching the web, you're going to want to try to think about how to design algorithms that look like this. Mathematically, this is called a logarithm, and it's log base 2 because I'm having again.
It's a punks.
That's so cool. Oh. Yeah, you're right. That's the first step, especially for a beginner. Because it's hard. I can barely sometimes get things to work.
Work is important.
But yeah, I guess once you like master that stuff, it's like then the really good programmers are the ones who design the beautiful algorithms. Like, that would be a dream.
Peach Teolingo says Karen.
You know, there's this saying they have in game development, because I've heard it before, and that's this: there's two kinds of game developers or game programmers. There's the good programmer and the good game developer, basically. So what that means is, like, you're either really good at coding but you suck at ideas and your game's not fun, but you're like really good at designing like algorithms and stuff, but you just are not, like, none of the stuff you make is fun. Or you're just like, you have really good ideas but you're just not good at like putting them into code, and it's like a mess. So I don't know, it's just like a thing they have, like a meme, I guess, in game development, which I think is funny. I already know which category I'm gonna go into, but I'm gonna try. This is why I'm trying to study math.
Again, but for now, just know that it's a fundamentally faster and different shape. So among our goals,
yes, it's different shape.
Ultimately, it's not just to write and solve problems correctly.
Says there are people that are a slight balance too. Smiley face.
Oh, cool! You're going for like business with it too. That goes nicely with it.
Ayaweza says NA. People who suck at coding just hid behind
I like the
excuses.
attitude, you know? I like it. You gotta... If you're not good at something, you gotta keep working on it. See, maybe... I mean, I would probably...
Peach Teolingo says
I'm not saying I wouldn't suck, but I would obviously... If I didn't give up on things so easily in my past, I would suck a lot less than I do right now. That's a fact. So... I'm not good at Japanese, but when I do study Japanese...
Ayaweza says you need to put the effort to study,
yeah,
understand, get better, etc.
Because I have noticed, I'm never gonna say I'm good, because I'm not, but like, I've noticed like when I have studied Japanese, like I do suck less, and that makes me happy. Grindset, mindset.
Sid says self-improvement
I like
is
that.
good. Smiley face.
I like that.
But ultimately, ever more efficiently as well. Any questions then on these ideas of efficiency and design? Any questions here?
I do kind of like this guy.
Ayaweza says that's only one that matters. WWW.
This guy is like super prepared to give his presentation. Like, I hope it'd be cool if all the teachers at Harvard were like this. I don't know what it's like to go at Harvard, but if they're all like this, they're pretty cool. I like too how every time he talks about a new topic, he never forgets to ask, are there any questions about anything? But no one asks any questions. Why are these people? Oh, maybe they're just like cutting it out or something. Because like literally no one asks any questions. But still, it's cool that he at least remembers to ask.
Ayaweza says the hard Bard guy. Prepared.
Hard.
WWWWW.
Who would have thought? I know, right? Exactly.
Yeah, and back.
Someone asked a question. This is the first time I've seen anyone ask a question during the whole lecture.
Smith says he's also given this presentation like 50 times.
Maybe. I think he said, I don't know, maybe, I think he said something at the beginning. I don't remember what he said. But in the old lectures, it definitely wasn't this guy. But yeah, maybe he has done it like a lot though. He's still good at it. I mean, I can do something hundreds of times and still be bad at it, so, you know.
Just to repeat, can a graph like this capture the accuracy of the algorithm? Short answer, no. For instance, if I drew a straight line that is super low on this graph, which...
I don't know, he's gonna talk more math. Why did he ask that question? You know what? Screw that person who asked this question. This is gonna make me like have to think about what his answer is. Okay, new line. If line's super low, which
would imply that the algorithm takes the same amount of time no matter how many pages there are. My algorithm might actually be to just pull a random page from the phone book, one step, and say, here.
Oh, hey.
Superbrain says, yo, what up?
What up? Just wrapping up here. Wait, so he's basically saying if it was a completely flat line, Oh, wait, then that would mean it was 100% accurate, because the time never goes up, because you could just pull the page of the person you're looking for from the phone book.
Ayaweza says those are called hash tables.
What are you talking about? Oh, what? Being able to just pull something? Pull the answer?
It is, but that's not necessarily going to be accurate unless I get really, really lucky. So the graph really only speaks to efficiency and the design of the algorithm, not the correctness of it. To analyze the correctness, you need to use another mechanism altogether.
Wait, how does that answer the question though of why the graph doesn't correspond to accuracy? I guess he's saying like if this was related to accuracy, then it would be flat or something. I don't know. But then that wouldn't make sense because you can't. It's impossible. Like, you can't just randomly pull the answer out of the phone book.
Namely logic. Other questions?
Namely logic.
This you need to use another mechanism altogether. Namely logic.
Logic will let you analyze if it's correct? Wait. Oh, wait, I think he's saying like that this isn't telling you whether the algorithm is correct. It's just telling you how quickly it gets down to one page. Because you keep tearing it in half. But that doesn't have anything to do with necessarily it being correct or not. Okay, this is what I imagine.
Other questions now on efficiency in this way. No.
Do not ask more questions.
All right, so...
Okay, good. Okay, this is a good starting point. 1 minute. Oh, sorry, it's not a minute. Numbers, I swear. 1 hour, 3 seconds. See, this is why I'm always getting questions wrong on freaking Khan Academy. Like, making little mistakes like that. Like, that's an hour. Ugh. It was fun, though. Well, not the math part, to be honest. But it was okay. I got through it. The video was fun. I like the doggy.
Superbrain says 1 minute and 3 frames.
LOL, that'd be funny. Oh wait, if that were true, I'd be really disappointed. Like, wow, I only got 1 minute and 3 frames in how many hours of streaming. So I would be very disappointed. But yeah. Well, I think I'll probably get off for a little while. At least until like way later. Oh my god.
Says we assume the accuracy of the algorithm is accurate to even put it on the graph. You can't compare algorithms that don't work with ones that work.
That's true too, what you're saying. That's what I thought at the beginning. Like, why would you even it doesn't even make sense to put it on a chart if it doesn't even work, because like it's not achieving anything, or I don't know. That's just what I thought too about it. Thank you, Aya. It's always nice when you say that. You work really hard too. You inspire me. You know that? You're one of the streamers who've inspired me. Because there were only 2 streamers I knew that were like hardcore studiers, or they did stuff like that. One of them's out of commission, but the other one, that's you. You still...
Superbrain says Stalin sword
like, I see you do like 10-hour...
also very wrong.
You know, you do like 10-hour, 12-hour streams. You're crazy. You work really hard. So I need to work hard too. I need to try my best. Stalin sort. Stalin? That's a real thing? Stalin sort. Oh. Oh, thank you, BC. And thanks for coming. Thank you. And thanks for always helping me out with things. It's really nice of you. And you always give me like cool facts and stuff. And I just like having you around. It makes the whole, just all of you guys, just when you show up, it just makes the whole thing so much more enjoyable and less painful. No matter how frustrated I get because I keep getting things wrong or whatever, like, it's bearable. That's the important thing. But yeah. Thank you guys. Hope to see you again. You too, Aya. If you keep working hard and you keep studying, and keep studying Japanese, and you keep studying math, and you do all the things.
Ayaweza says, I just noticed there's a guy with a Joker costume in the crowd.
What the hell? How are you that observant? Where? Oh my god. It's the guy with the green hair, right?
Smith says, intend to make it easier.
Oh, thanks. Well, you do. Oh! Oh, it could be a new Balloomba too. Well, I can't believe you guys noticed that. I thought this is about computer science, it's about math, algorithms, and then you guys are just paying attention to the green hair dude, the Oompa Loompa. Oh, I never would notice that. I'm like looking to see if there's any more details. Oh, that's why you said, didn't Superbrain, you said earlier, you're like, it looks like Hogwarts. It does, like the logos on the panels, the wood panels. I don't know if you're the one who said that or not, but someone said that earlier.
Superbrain says, I don't think I did.
Oh, okay. But yeah. I didn't know what they meant. At the time when they said it, they were like, it looks like Hogwarts. I was like, I didn't know what they meant by that, but now I do. I just realized by looking, like, wow. I get it now. Yeah.
Superbrain says there is also a very subtle duck visible just in frame.
Oh yeah, I did see that one before. It's in front of the computer. There's ducks hidden everywhere. I don't know what it is with ducks in this course. But like, yeah. Alright then.
Superbrain says, oh wow, I actually meant the giant one. Didn't even see that
Oh, okay, I thought you meant the one in front of the laptop. Oh yeah, big duck. How could you? Everyone would probably notice the big duck on the right, because big duck. Yeah. I wonder what these problem sets. Okay, well, I want to take a sneak peek. I know I said I was gonna go. I will go.
Smith says there is a duck method. Smiley face.
I just want to see. Okay. Oh, wait, this is technically supposed to be for Scratch. View scripts. I'm guessing. Oh wait. Should I actually do... No.
Ayaweza says LUL.
I'm trying to think if I should actually do this, but it's in Scratch, and I kind of don't want to... Scratch is kind of not very pleasant to use, because it's like kind of slow, and you have to drag blocks, and it takes forever. And like, I'll probably just skip the Scratch project, and start doing the... I'll do all the projects, though, but just not the Scratch one. I'll do the ones that use real code that's not Scratch. But no diss to Scratch. Scratch is really cool and you can do a lot of stuff. It's just really time consuming. Because it's just dragging blocks. Yeah,
Ayaweza says I found hilarious that some schools force you to learn Scratch instead of just using normal code.
Force you? That's kind of crazy. I feel like, wow, I feel like Scratch can be useful, like it's an introductory tool, and great for like kids. Well, that's what it was actually made for, but still, I don't think you should be like forced. As soon as you outgrow Scratch, people should be allowed to move on.
You are like 4.
problem. Think out loud to rubber duck. Really? Do you think that's where these ducks come from? Like they're making a reference to that? Because, you know, Harvard's all about, like, you know, academics, and I'm sure they're, like, you know, into, like, psychology and stuff like that. I wonder if that's where that came from. You explain what you know about your problem and think out loud to a rubber duck. That's a real thing? That's crazy. So if I just, like, start talking to a rubber duck, I can just say, like, I'm not crazy, I'm using a real method in psychology.
Smith says probably. Smiley face.
Ooh, well this course goes straight to C. They choose to teach with C. That's why week 1 is C. You go C, Python, SQL, and then you finish with HTML, CSS, and JavaScript. Which I think is really cool. Like, it sounds perfect, because I actually really wanted to, like, learn about C, because C kind of makes up so many, you know, C is like the backbone of so many other programming languages.
Also sounds like a good way to get schizophrenia.
Oh. That's crazy. You went to C and assembly. Wow. Assembly sounds really hard. But yeah. I think it's really fun, not just for learning the basic concepts, but I'm really fond of the languages that they're using in the course. Like, I wanted to learn more about Python, but I really wanted to learn about C too. And SQL was something I wanted to learn about.
Ayaweza says ain't hard.
I haven't really learned anything about how to work with databases, so this is going to be a really cool introduction. Rubber duck debugging. Yeah, that's true.
Ayaweza says it's just a matter of syntax.
True. But I think these ones will be particularly, I don't know, they match my interests, and they'll be particularly, especially like C, will be particularly useful for, like, game development and stuff. You know, because different languages have, like, more libraries that support certain kinds of activities and stuff. Like Python being good for machine learning. But yeah. All right. How long? Okay, now look at the time. I didn't want to, while I was doing the math stuff, I didn't want to check.
Ayaweza says if you want to make games, forget about Python
and
HTML, etc.
Honestly, my interest in Python is partially because machine learning is kind of interesting, but also Python because my friend, like my good friend, is like a Python programmer, so it'll give us like stuff to talk about, you know, and then they'll be able to like, you know, give me better feedback on like my code and stuff.
Superbrain says, but
easier.
If you want to do math, get into Python and MATLAB and R.
But I don't like want to do math. I'm just putting up with math. I don't like math. I just deal with it because it's important for what I want. Once I learn enough math, like it's like this. So yeah. I don't want to learn math for the sake of math. No way. Because once I learn enough math, I swear to God, once I learn enough math to accomplish my personal goals, I'm done. Like, I don't want to learn anything extra. That's how I feel about math. I just want to be able to accomplish what I want, which is I will need math.
Smith says he.
There's never enough math.
Smiley face.
But you know what? I'm starting to warm up to it, but day by day I'm warming up to math more and more. So that's good. So my feelings could change about that. But at least I acknowledge that it's just absolutely essential. And I'm making it like a core part of my studies now. What's wrong? There's nothing wrong with math. It just puts me to
Smiley
sleep.
face.
I'm sorry, BC. That's it. It just knocks me right out. That's all. It's not math's fault.
Ayowaza says LUL.
It's probably my fault, but still. Anyway. No, maths. I think I've said, I don't know if you were around, BC, when I said this, but the way I feel about math is it's super interesting. It's never not been interesting. It's one of the most, I think it might be the most interesting subject ever, because it just describes the whole world. Like, everything can be described in mathematical terms, and it's really beautiful, and it's so interesting. Like, the way, like, if we discovered aliens, that would be super interesting to know, like, what they're like. Like, math is like that. But, yes, BC, but,
Smith says, are you J Learner on the Discord?
it's not fun, for me at least. It's interesting, but it's not fun, which is really interesting in itself. So that's the duality there, that they're constantly pushing against each other, because it's not fun, but yet it's still super interesting to me. But the good news is that the interestingness of math is starting to overpower the not funness of math.
Ayowaza says you don't find math fun because you don't use it.
But oh yeah, that's true. Oh, only when I'm, yeah, I wouldn't say only when I've been forced or answering the
Ayowaza
contact.
says
You're right.
So far you have been forced to use it.
That's a good point. Like, that could change once if I get better at it to the point where I can use it myself for my own
Smith says,
personal needs.
I'm an alien. Thanks.
Aliens are cool.
Smiley face.
I love aliens. That's literally like one of my favorite movie franchises ever. I love aliens. I'd rather be an alien than a person, because people suck. I don't think I need to explain that in detail. But aliens are probably awesome. Need to use it.
Ayowaza says I started to like math when I actually needed to use.
I hope I'll feel like that too once I start to be able to, because I'm learning, because I want to be able to apply it. That's why I want to really understand. I don't just want to be able to like solve the formula, but I want to like understand why I'm using the formula and what it can be used for, and like really understand what I'm doing with it, so that I can use it, and then maybe it will be more fun once I get the opportunity to use it for something cool that I think is cool. But yeah, that's gonna be a while. Well, it's just maybe one day. I hope so. They never. No, I never learned anything. The only thing my school cared about was the standardized tests, because they just didn't. They just wanted to, like, you know, not get fired. That's really it. It's kind of sad when you get taught by a teacher. I mean, it's not really I'm not blaming them. It's like the whole system, but it's sad when you get a teacher and you know they hate their subject. They hate what they teach. Like, it does, you know. Students know. They feel it. What, anyway?
Smith says, are you in high school
Nope,
or
nope.
college?
Just studying on my own. Anyways. I'll see you guys. Sorry, I always take forever to say goodbye, but I think that's fine. I deserve it. I worked hard. I deserve to have fun and talk to people. And take my sweet time whenever I want to. Ha. Mata. What is this?
Says.
Bye? Oh, bye-bye. Okay, I remember now. Okay. That's bye-bye. Lol. Aww. Mata bye-bye, Aya. Bye-bye. Aw, thank you.
Smith says, I see. That's cool.
Yeah, that literally says, yeah, that's literally what that is. It's no funny. Thank you, PC.
Smith says take care.
Okay.
Smiley face.
Anyway, hope to see you guys again. But seriously, have a great day. Have a great day, guys, okay? Take care of yourselves. So, okay, bye now, for reals. Bye!